Hello, am
Yes,
I
ma'am, you
audible,
can
sir?
start. Yes, you can
Yes.
start.
Okay, sir. Okay. So let's start today's session. Good morning, everyone. A very warm welcome to all the distinguished participants, esteemed speakers, and organizing members joining us today for day 4 of our faculty development program on smart health innovation, integrating imaging, sensors, and biomaterials, jointly organized by Department of Biotechnology and Bioengineering, School of Biosciences and Technology, Galgotias University, and Department of Applied Mechanics, MNIT, Allahabad. I am Dr. Anjali Priya, and I will be your host for today's session. We are very delighted to have with us an esteemed panel of speakers today who are pioneers in their respective fields, and we look forward to an insightful and intellectually enriching session today. So, without further ado, let us begin the session. So, it is my great pleasure today to welcome our first speaker of the day, Dr. Sumit Tripathi, sir, from the Goa Institute of Management, Goa. Welcome, sir, to today's session.
Thank you.
Dr. Sumit Tripathi is an associate professor at the Goa Institute of Management, Goa, India, with over 15 years of experience in academia and research. Sir has completed his postdoctoral studies at Linköping University, Sweden, and earned his PhD from the Indian Institute of Technology, BHU, Varanasi. Dr. Tripathi's research interests include artificial intelligence, generative AI, machine learning, deep learning, computer vision, and biomedical image processing. He works on applying deep learning methods to address practical challenges in biomedical imaging and related fields. Dr. Tripathi has contributed to various research publications in international journals and conferences. As a lifetime member of the Indian Society of Technical Education, ISTE, Sir has dedicated to supporting engineering education and research throughout his study. Dr. Tripathi today will be speaking on a highly topical subject titled The Art and Science of Prompt Engineering in Generative AI for Biomedical Engineering. We are very honored to have you, sir, on this platform. Over to you, Dr. Tripathi.
Thank you. Thank you for this warm welcome. So without wasting much time, I'll start the session. So I'm
You can
sharing my
share
screen.
your PPT, sir.
Yeah,
Yes.
I'm sharing the screen. Let me know if it is visible. Can you see my screen? Is it?
Not yet, sir. Yes, sir. Now we can see. So please make it in full screen
Yeah,
mode.
sure. Sure. I'm doing it. It's good now?
So it's not full screen yet. You can
Just wait,
click the
ma'am.
slideshow button, the
Wait,
blue
ma'am.
button
I've
in the
connected
bottom
two
part.
screens. That's why this is creating some
Okay.
issue.
Yeah, now it is full screen.
Now it is full screen? No? Yes, okay.
Yeah, yes.
This was issues into second of page. Okay, I'm working on it.
Yes, sir. Yes, sir.
Okay,
Continue.
so shall I start
Yes, sir.
now?
Go ahead,
Yes,
sir.
okay. So good morning, everyone. So the topic of today's lecture is the art and science of prompt engineering in generative AI for biomedical engineering. Here I will talk about the basics of prompts, then prompt engineering, and then various prompt patterns. I wish to cover at least 5 patterns today. So how you can apply these patterns in biomedical engineering or in any other sector wherever you are working. So I'll come to the very first slide. So this is the introduction to prompt engineering. So prompts are basically questions, queries, or set of instructions or whatever you say, which you give to the large language model for collecting some responses, right? So the whole idea behind structuring your words, structuring your sentences is such that so that you can elect the best output or the best response which you intend from the LLMs. So prompt is can be defined in a single line that it is just a query which we ask to a LLM for getting the better response. So uh, we can classify broadly the prompts into two categories: temporal on the basis of temporal dimensions. One is immediate prompt, other one is long-term prompt. Although there are many other categories as well, but broadly we can categorize into two categories: immediate and long-term prompts. Immediate means the response is real time and response is static. You did not to indulge in the conversation with the prompts. You did not to indulge in any sort of conversation to shape your query and then get the response. The example is on the screen. That what is the capital of France? The answer is straight up, right? But sometimes you have to indulge in some conversation to shape your query and then get the corresponding output with whatever you want. So such type of queries comes under the umbrella of long-term prompts. We are going to discuss in detail on long-term prompts in this lecture only. So before moving towards the prompt patterns and all, we have to discuss few basics and then we will be moving forward. So this is the very first one, context in prompts, right? So context is something which is very, very important when it comes to prompt and prompt engineering, right? It basically gives the intent of the user to the LLM, what basically user want, right? What is the purpose behind asking this question and what type of response should be given by the LLM to the user. Otherwise, if the context is not being provided, then the response from the LLM could be a bit vague, which should not be of any use to the user. So providing context means a lot when you are prompting a LLM. So prompt engineering. So prompt engineering is nothing, but it is basically art or science, whatever we can say, of crafting the prompts. How well you design your prompts or queries to get the best response out of LLMs. This comes under prompt engineering. So the best practices for prompt engineering. So clarity and specificity. These are something which comes under the umbrella of best practices of prompt engineering. Whatever prompt you are writing should be very clear and specific. I have given two examples here, vague prompt and clear and specific prompt. The vague prompt is tell me about climate change. So it's vague. Why it's vague? Because it's broad. And every time you need not to have the broad answers. We are researchers working in specific fields, so we need some specific responses for our queries. So see the second prompt, clear and specific prompt. Explain the primary cause of climate change and their impact on global temperature. It's more specific, more clear, and the context is given in this prompt that for what reason you are asking that for the climate change, right? So avoid being ambiguous while writing your queries. So this is the first best practice, clarity and specificity. Then context, I talked in the last slide only. You need to give the context to your query. Context is very, very important. Otherwise, the response from the LLM will be broad and vague, right? Just to have a look at the examples, describe the benefit of exercise. This is a very general type of question. You will get a generalized answer for that, not a specific one. But the second one, as a fitness coach, describe the benefit of exercise for cardiovascular health. So this is having a context that assume the role of a fitness coach and then tell me the benefits of exercise for cardiovascular health. Right? So it's more contextual. The context is given in the second prompt, while the first one is a broad and general and vague one. So there are two types of framework when it comes to prompt designing. And the first one is on your screen, that is SPEC, SPEC. There are four words, specificity, purpose, example, and constraints. So specificity, as we talked, that we have to explicit, we have to be clear while writing the prompts. Then purpose or intent should be there. Then, if possible, provide examples also in your query so that LLM should focus on the specific points. And if you have some constraints, provide those constraints as well, right? So it comes to specificity, just have a look at the example, list 5 benefits of meditation for mental health. So you are asking for benefits of meditation and for what? Purpose is mental health. Then see the example of purpose to use in health blog article. You want to write a health blog article, and for that purpose you need the points on meditation, right? So here you are defining your purpose. So if you are writing prompts in such way, then you can yourself see what kind of responses you are getting and how they are beneficial. I'll show you a few examples over GPT portal as the lecture will progress. So if possible, provide examples as well as given on the screen. Then constraints. If you have word constraints or if you have minimum number of words, so you have to set those constraints also. For example, in 200 words, explain so and so. In 500 words, explain a particular topic. So constraints we have to define. So this is the first framework, and the second framework, almost the same, the 3C framework. This consists of three C's: clarity, context, and completeness. Clarity, obviously, we have to be clear, not ambiguous. Context means you have to provide the purpose or intention or the background, as we talked in the previous slide as well. And it should be complete also. Sometimes what happens when user writes their queries or prompts, they forget to input all the details. This should not be there. Completeness should be there. So 3C framework gives you clarity, context, and completeness. Don't forget to include each and everything in a single prompt or single query. Otherwise, you have to indulge in the dialogue with the LLM. Now include this, now include that. So this should not happen. So what are prompt patterns? Prompt patterns are nothing but basically an art of writing the prompts. They are basically the templates. They are common general templates which are provided to the user. Use those templates and get the best outputs. Right. So it evolved over the period of time. When people started using AI LLMs, so they discovered that if they are working on certain patterns, if they are writing their prompts or queries in certain way, then it is more good for them to get the better outputs. So you can see on the screen that I've highlighted a text that think of prompt patterns as helpful tricks or recipes for talking to an AI, ways to organize your requests so the AI understands you better and gives you what you need. So it's basically crafting your question or query in such a way that you can elect the best out from the LLM. It's nothing, it's like a recipe to give you good taste in kitchen. If you have a good recipe, you get good taste. Similarly, if you are having a good prompt, if you are writing a good prompt, it's like that you are going to get the best output from the LLM. So now on the screen you can see the very first prompt pattern. It is persona pattern. So persona pattern is extremely powerful pattern when it comes to large language models. Here you have to instruct a model by saying as, act as, right? These patterns are useful when you know in real time whom to approach for solving a specific problem, right? So you can ask LLM to play the role of that particular person or that particular means professional, and then give you the correct responses accordingly. So this pattern is very useful, and I'm going to show you few examples on the ChatGPT portal how you can use this and what type of responses it is going to give. So I have to open. Yeah, is my screen visible to all of you? Can anybody confirm?
Yes, sir.
You can see a Word file open.
No, sir. The PPT is still visible.
Okay, I have to share again, right?
Yeah.
Now GPT portal is visible.
Yes, sir. Yeah.
Yeah,
ChatGPT is
okay.
visible.
Now Word file is also there on the screen,
No.
right?
Yeah.
Word,
Now it is
Word.
visible.
Okay. So just so now have a look there on your screen under persona patterns. You can find the format of persona pattern. To use this pattern, you have to ask LLM to act as persona X. To act as persona X. This persona could be anyone. act as a business development manager, or act as a doctor, act as a biomedical engineer, act as something and perform task why. Okay? So this we can perform few exercises on this GPT portal. So here the first example which I have given, act as a biomedical engineer is specialized in ECG signal analysis. So I'll just copy paste it just to save
Yes,
the
sir.
time. Yes.
Sir, some of the participant is asking you to increase the volume. You need to
Okay.
speak bit louder.
Bit loud. Okay. Okay. Okay.
Okay, sir.
I think
Sorry to
mic is
disturb you.
no problem. No problem. No problem.
Yes, sir. Just increase the volume.
I'm doing that.
Probably the mic went backward.
Yeah. Mic went back. That's why it was
Uh,
behind follow, so it might. Okay.
okay, sir.
Now it's fine, or I have to speak a bit more loud.
I'm okay with the previous sound also, but
But others participants, let them
they are
complain
bit.
again if there is some issue. So
Uh,
yeah, I'm keeping it near my lips.
I
Yes,
will
sir. Go
message
ahead,
and
sir.
ask.
Okay, sure. Okay. So what I am giving to GPTs right now is act as a biomedical engineer. Act as. So assume the role of a biomedical engineer who is specialized in ECG signal analysis. So this I am giving.
Okay.
So its response is as a
Now
biomedical
it is
engineer.
okay, sir.
Okay. Thank you. So this was the instruction or prompt. Now I'm asking this question. So I don't know the answer for this. You people are biomedical experts, so let me know whether the response is right or wrong. It hardly matters. But so it is acting as a biomedical engineer who is specialized in ECG signal analysis. Now the question is there: analyze the following ECG RR interval in milliseconds and tell me if there are signs of arrhythmia or abnormal heart rhythm. Now see the response. It is giving you the response, and it is calculating the heart rate and all, and it is giving you a technical kind of response, right? Without doing this, if you have given this question, it would have given you some sort of means generalized kind of answer. So you can do this exercise when this lecture gets over, because I have to cover at least 5 patterns. That's why I'm not doing that. So I'm just focusing on telling you the prompt patterns. So whenever you say act as, it will assume the role of a particular persona, and accordingly it will give you the responses. So just for your exercise, without giving such type of instructions of assuming a role, do ask LLM to give the response for this question, and again you can do this for the persona, and then you can compare both the responses. Right? So one more we can try as a biomedical imaging specialist. Act as a biomedical imaging specialist. I'll clear this first, otherwise the previous response can have an impact. So now we are asking it to be for playing the role of a biomedical imaging specialist. And now the question here is, as a biomedical imaging specialist, I can say that the early signs of multiple, sorry. It should not be this. Explain the abnormalities in, this was the expected response. No. Explain how abnormalities in MRI scan data could indicate early signs of multiple sclerosis. So just see the response. So whenever you are asking it to act as someone, or act as a particular persona, or act as a particular person, the answer will be more technically oriented towards that kind of persona. This you can feel while having a look at these responses. Right? So this is about persona pattern. Just you have to, I'll again show you the format for this. Act as persona X and perform task Y. Right? Act as a biomedical engineer. Tell me the benefits of MRI over other kind of modalities. This kind of questions you can ask. So you have to craft your query accordingly. Act and perform. So I'll move on to the next persona. Sorry, next pattern. Next slide. So this is what I showed you on the Word file that yeah. So identify the persona. Whatever persona you are, you must be approaching into the real life. You have to identify that and then ask a question, and you will get the content. So uses just we discussed. Whenever in real life you know that whom to approach for solving a particular kind of person, ask LLM to play the role of that particular person or a professional, and then you can ask your queries accordingly, and you will get the response. So our second pattern and the most important pattern is cognitive verification or cognitive verifier pattern, right? So cognitive verifier pattern basically breaks down a complex query into smaller queries or a complex question into smaller questions, and then it asks for the answers of those smaller questions, and then it accumulates all the smaller questions answers, and then it gives you the answer for the overall complex query. So just have a look at the steps. It decomposes the query into subcomponents, generates specific questions to address individual components of the query, and it synthesizes the answer accurately for the detailed responses. So I'll discuss all the slides and then I will go to the portal again. Otherwise, I have to jump again and again. Yeah. So what are the basically benefits of cognitive verification? So it enhances the precision in responses. Why? Because here user involves in dynamic dialogue with the LLM. Dynamic dialogue means it's like a conversation with the LLM. You ask something, and if LLM does not have specific detail, which details are available with you, it asks for the details from you, and then it will synthesize its answer accordingly. Reduction in miscommunication between the system and the users. When it is when you are in a dynamic dialogue with the LLM, then the miscommunication issues reduces a lot, right? And it promotes deeper understanding through the detailed responses as well. Just for an example, if I ask LLM a vague type of question that how many mosquitoes are there in my courtyard, right? So do you think that it is going to give any answer? The answer is no, because LLM don't have idea about my courtyard. So it will ask for the area of the courtyard and then atmospheric conditions around my courtyard and so many things. And then it will be able to give answer. And in real time, if you are asking this question to anyone who is not aware of your geographical location, then it's very hard for anyone to answer. And that person will also ask you the same thing in which place do you live, what is the area of your courtyard, such kind of questions. So cognitive verified patterns are the same. When you ask some query to the LLM, it will generate some sub questions, and you have to answer those sub questions, and accordingly it will give the responses. So I'll again show you the word file where its pattern is given. Now on your screen, you can see format for cognitive verifier pattern, right? So just have a look. When you are asked a question, follow these rules. When you are asked a question, follow these rules. Generate a number of additional questions that would help more accurately answer the question, right? Then combine the answers to individual questions given by the user to produce the final answer to overall questions. This is what you have to supply to the LLM when you are indulging in such type of prompts. So for limiting, I'm adding few more things to generate only 5 questions. Okay, so now it is ready for cognitive verified patterns. Now I'm going to give you question to it? Now the question is, or the query is, tell me the heart disease risk for a patient based on their health data, family history, and lifestyle. Just wait. Now it will work. Now it is asking for the specific details. Now my question is, tell me the heart disease risk for patient based on their health data, family history, and lifestyle, right? So now it is generating several set of questions, sub questions, because it needs specific details, right? Tell me the heart risk for a patient, right? For a patient, there is no specific detail. Now it is asking for specific details, right? So you can see what are the patient's key health parameters. It is asking for age, blood pressure, cholesterol level, blood sugar, BMI, so on, right? So I am giving it the blood pressure at as normal. It will understand BP, and then cholesterol level as normal, and then leave rest of things. I'll jump on the second point. Is there a family history for heart disease? I'll mention it as no. Then third one, what lifestyle factors are present, smoking status, and also I'll keep it as no. Then does patient have any existing medical conditions? I'll keep it as no again. 5. Are there recent results from diagnostic test, TCG, any? Now let's see what response it is giving. So based on the inputs provided by the user, it is giving you a final recommendation. I'm not going to read this. So just to recall that for cognitive verification purposes, for such type of things, you need to ask LLM to generate sub questions, specific questions if it needs the detail, and then based on those sub questions, it will be able to give you the specific responses. So here what we did, we asked it to generate questions, and then it will combine the questions and give you the specific answer. Our question was, tell me the heart disease risk for a patient based on their health data, family history, and lifestyle. So it didn't knew any detail of that patient. So it asked for those details, and it is giving you the answers. I'll show you one more example and then move on to the next pattern. So just have a look. Yeah. When should we service the MRI machine based on the sensor data and past repairs? So again, it is generating several set of questions which are specific to this questions or sub components of the question, and based on these sub components, it will give you the final answer. So this could be done by you later. I have to cover some more patterns. So this was about cognitive verified pattern, where it decomposes the complex query into subcomponents, and then it gives you the specific responses. Yes. So when to use these patterns, right? So when you are supposed to be more reasonable on your queries, then you have to use such type of patterns. It reduces the it increases the transparency of the responses, right? Because it asks for the specific details, and by using those specific details, it gives you the responses. So for transparency purposes, this pattern is very, very useful. So now we can jump on to the next pattern, that is the question crafting pattern. So just have a look at this question crafting pattern. So question crafting pattern, it's basically a technique to shape your queries or questions in such a way that you can get the intended response. Sometimes users can ask vague kind of question. So the crafting of the questions or the details of the questions is very less. So what you can do, you can instruct the LLM to generate a good question instead of your questions. You can start with a vague question and you can end up in getting good questions from LLMs. Just have a look. So steps here are: number one, formulating an initial question that will be formatted by the user and then refined by the LLM. So you can ask LLM to refine your question, add the specific detail and make it more viable. So best practices for question crafting: understand the context of the query. First of all, users should know the queries and then specific details to be added in that. And then those details should be aligned with the goal of the conversation. Role of the language models in question refinement, right? So here LLM acts as a feedback loop between user and the system during refinement. You ask an initial question, and and if it is vague, it will add LLM will add specific details to those questions, and then that question will become more useful for getting the desired responses. So just have a look again on the format. So this is format for question refinement pattern. Right? From now on, whenever I ask a question, suggest a better version of the question to use instead. So whenever you are asking a vague question, it will rectify that question and give a better question instead of that. So we can have a look at one or two examples. I'll take this. So from now on, whenever I ask a question about biomedical device design, suggest a better version that focuses on optimizing device parameters for safety and efficacy. So now we are instructing LLM to suggest better version of the question. The question we are giving, but if it is not a good one, a vague one, it will suggest a better version of the question. So I'm giving a question to it. How fast should 3D printer print? So see the better version of the question. It's a bit vague. Now, what is the optimal printing speed for 3D printer used in biomedical device fabrication to ensure both structural integrity and patient safety while maximizing print efficiency? If you are going to give this question directly, the response will be a vague one. And when you are going to give this question, which is being crafted by LLM as a better version of the question, the response will be more technical in nature, detailed in nature, and that will be more useful. So keeping that in mind, the question refinement pattern is also a very useful pattern. If you are not sure about your question, what specific details should be there, then you can ask LLM to refine those things. So coming back again. So advantages of question refinement patterns, it increases precision and it is more efficient because you can save time by asking LLM to create the better version of the question, right? So the time could be saved and the responses will be more accurate and precise. And relevant and targeted responses will be produced by LLMs learning. And by involving in such type of patterns, the user will learn more about crafting the questions. So over a period of time, user will also learn how to craft a good question. So just this we discussed that when to use and use the scenarios and all. Whenever we are unsure that our question is a bit vague or we have to add some more details to it, then these patterns are useful to use. And next pattern is in a recipe pattern, right? Recipe pattern, as the name suggests, right? as a name suggests, if we know some part of a problem, some part of the problem. Suppose we are having something. Let's take a real type example from kitchen only. If we have some vegetables and if we have to prepare a mixed veg curry, and but we don't know how to prepare the mixed veg curry. We know how it looks, how it tastes. We know what are the ingredients, but we don't know the process how to cook that. So in such cases, recipe patterns are very useful. Whenever we have the some missing or some missing steps or gaps for completing a particular task, then we can use these type of patterns. The name itself suggests that recipe patterns, we need a recipe of doing something or performing some task, right? So here what we have to do, what we have, what user have or what we have, this we have to specify to the LLM, and what we want, this also we have to specify to the LLM, and then we can ask LLM to give the missing steps. So this is what comes under the umbrella of recipe patterns. So steps I just narrated, that define your information, what you have, then mark the missing information. This is optional. The second step, mark missing information, is optional. You can just craft it using your words or sentences only. That's not an issue. Then request for the completion for LLM, that this we have. Now we want to do this. Tell us the process, right? So this we can go. We can again go to the format of recipe pattern. This is the format. I would like to achieve X. I know that I need to perform steps A, B, C. Provide a complete sequence of steps for me. Right? So as I told, that what you have, this you have to tell. What you want to achieve, this you have to tell, and then you have to request for completing the steps. Right? So we have to instruct the LLM in such a way that it will give you the missing steps. The some steps you have, final output you know, but the intermediate steps will be provided by LLMs. So just have a look, few examples. I will take this example, bioprinting process. So I would like to optimize a 3D bioprinting process for cartilage tissues. I know the steps involving preparing the bio ink and printing the scaffold. Provide me complete sequence of steps for me. Fill in any missing steps, right? So what I have, this is specified. What I want to achieve, it is specified. And we are asking for the steps to fill in the steps. So just have a look here. We have to define what we have. We have to mark the missing information, and then we have to request for the completion. All the things are there in this prompt. Let's see. So it is giving you a detailed response. So those who are from this field can relate with it. So just as the name suggests, recipe patterns means you want recipe of performing some task or solving some problem. Few things you know, few things you don't know. So you have information in bits and pieces, and you have to complete that information. And in such type of scenarios, you can use recipe patterns to fill in the gaps and complete the process. So this is how recipe patterns works. So these are the examples here. And all the examples here are under the umbrella where you know some information and you have to complete the steps. So as we discussed that, sorry, we can use these patterns whenever we have some information, some to ask for LLM. Next and the last pattern is next and the last pattern is semantic filter pattern. Semantic filter pattern. So this is again a very useful pattern where we can selectively extract the information from a particular document or a particular response. It is useful whenever you want to hide some sensitive information or remove some sensitive information from a particular document or a particular report, whatever you can say. So these are basically designed in such a way that if you are removing the some contents from from any document or any report, then also it will be meaningful, but sensitive information could be hidden there. So it will not change the meaning of whole document, but only it will filter out the details which are very sensitive in nature, which you want to hide. So use cases: if you want to protect the privacy of a patient, then you can use this. And if you want to maintain the clinical meaning by preserving the essential medical context and data integrity, then you can use this. And if you want to secure your data for research and all, whenever you are sharing your data, and if you want to hide some information, then you can use this kind of patterns. So this is the last pattern. I'll show you some documents. So semantic filter pattern. Format for using this pattern is filter this information to remove X. Right? Whatever you want to remove, you have to specify here, and then it will work. So one example I am having here, it is a clinical note of a patient. Patient's name is given, and age is given, gender is given, and some diagnosis report and all it is given. So if we want to hide some information, just have a look at the prompt from the text below or above. Remove all the personally identifying information, including name, exact age, appointment dates, medical doses, and so on. If you want to remove specific details that it should be anonymous, right? Then you can use this to, and moreover, the text should be meaningful. It should not be like that only the patient name is extracted and rest of other things are blind. So this should not happen. So what we can do, what we can give this prompt to LLM. Before that, I have to clear this. Yeah. So prompt given is from text below, remove all the personally identifying information, including name, exact age, appointment dates, medication doses, and so on. So I'm giving this text to the LLM. Now, what it is doing, it is removing all sort of personal informations, includes name, age, gender, such kind of thing. And it is giving you a generalized kind of information, right? Where medical history or medical diagnosis is there, but no personal identification kind of information is present. Right? So this is about semantic filter pattern, where if you want to hide something, if you want to extract something, you use these patterns. Semantic refers to meaning. So it will not change the meaning of the document, but it will hide the information which you want to hide. So when to use, just we discussed that for extracting something or for hiding sensitive information, we can use this. So with this, I come to the conclusion of this presentation. What we discussed is prompts and prompt engineering and few patterns on prompt engineering, like persona, cognitive verification, question refinement, recipe pattern, and semantic filter patterns. Right? When it comes to persona, you can ask LLM to act as a particular professional or a person and give responses accordingly. Cognitive verification includes where some specific complex details are needed, then it can generate several set of questions, and those questions are to be answered by the user, and then it will synthesize the final answer. When it comes to question refinement patterns are concerned with refining the vague question and converting it into the question which is more meaningful, and which will be useful for the LLM to elect the better responses. Recipe patterns, when informations are in bits and pieces. Some information we have, some we don't have. So we can ask LLM to complete the missing steps, and then we will be able to solve a particular problem. Semantic filter, the last one which we discussed, semantic filter was about hiding the sensitive information or extracting particular information from the document. So it's very useful when it comes to sensitivity or privacy. So these things we discussed. And in the initial part of this, we discussed what basically is prompt, how to structure a prompt, what are the basics, or what are the basic frameworks of the prompt, how a prompt will look good, how to prompt LM in a better way to get the desired response. How to add a context. This we discussed during prompt patterns. Okay. So this comes to the conclusion of my presentation or lecture. So now whatever time is left, I can take the questions if there are any.
Thank you, sir. That was a very informative session, and I hope our participants have learned a lot from this session. I can see one question in the chat box from
Actually, I
Professor.
have, sorry, ma'am, I have
Yes, sir.
unmuted, I have granted permission to unmute yourself. Participant can ask question.
Okay, okay.
Uh, but you can convey the message, ma'am, what you
Yeah,
wish to say.
yeah. So I can see one question in the chat box from Professor Prabhat Kumar Srivastav. Sir, you have not considered blood sugar and BMI. So if Professor Prabhat Srivastava is here, he can ask the question. In what context you are asking this question? Professor Prabhat Srivastava?
I believe actually to answer that question more than Sumit sir, I can answer. It is
Okay,
just
sir.
an example which sir has taken.
Yes, yes,
Yeah.
yes.
It is more than an example actually. So it's up to
Okay.
you. If you wish, you can consider all the other parameters too.
Mm.
Yes.
I'm right, sir.
Yes, yes, you're right. Because see, this was just an example. So I'm not expert of that. So whatever details are needed, you add those details, right? Yes. Another question? Anything?
And I believe not only in biomedical engineering, we can apply this prompt engineering technique in any other field, sir.
Ma'am, it's very general thing, right? So I was
Yes,
bound to
yes,
talk about biomedical things. That's why I
yes, sir.
included those examples where you can
Yeah,
use these things in any field of the life. That's
any
not an
field
issue.
of research. Yeah. I think
Ashok Behra, sir.
Ashok Behra. Yeah, you can
हेलो
ask
सर,
questions, sir.
नमस्कार सर। सर
Namaskar.
नमस्कार सर। सर
Namaskar. Namaskar.
सर आपका इंफॉर्मेशन तो हमने सुना, मगर मैं
हाँ,
समझ नहीं सका कि मैं उसको मेरा रिसर्च में कैसे अप्लाई करूं। मैं बेसिकली हेल्थ केयर में डील कर रहा हूं, तो ये
हम्म,
क्या मैं ये कोई भी बीमारी का के लिए अगर जानना चाहूं तो उसका सॉल्यूशन के लिए चैट जीपीटी को पूछूं, या क्या मैं समझ नहीं सका एक्चुअली इसमें क्या करेंगे। उसके चैट जीपीटी से आपने जो क्वेश्चन
हम्म,
किया और जो दिखाया वो क्लियर नहीं हुआ मुझसे। बाकी तो हो
हाँ,
सकते हैं दूसरों को, मगर मुझे नहीं हुआ सर। इन ब्रीफ अगर
हाँ,
आप जो थोड़ा बता दें
हाँ,
तो अच्छा होगा, थोड़ा समझ सकते हैं।
हाँ जी। देखिए, चैट जीपीटी से किस तरीके से बेहतर आंसर लेना है, उसके लिए प्रॉम्प्ट पैटर्न्स का हम प्रयोग करते हैं, ठीक है। और चैट जीपीटी को किस तरीके से हम और बेहतर बना सकें, रिस्पॉन्स सॉरी चैट जीपीटी के रिस्पॉन्स को कैसे बेहतर बना सकें, ये बातें मैंने करी हैं, ठीक है। तो पर्सोना पैटर्न फॉर एग्जांपल मैं लेता हूं। तो पर्सोना पैटर्न एक ऐसा पैटर्न है जिसका आप इस्तेमाल करके आप चैट जीपीटी को वो आदमी बना सकते हैं जिससे आप रियल लाइफ में आप क्वेश्चन पूछ सकते हैं। फॉर एग्जांपल कि अगर आपको अपना बिजनेस एक्सपेंड करना है तो आप उसको बिजनेस मैनेजर की तरीके से यूज कर सकते हैं, ठीक है। आपको अगर उसको यूज करना है, कह लीजिए कि आपको इंस्ट्रूमेंट यूज करते हैं, उस इंस्ट्रूमेंट को जिसने मैन्युफैक्चर किया, आप वैसा पर्सोना आप उसको एक्ट करने के लिए आप बोल सकते हैं। तो वो आपको जनरलाइज्ड और स्पेसिफिक रिस्पॉन्सेस अकॉर्डिंगली वो प्रोवाइड कराएगा। ये एक एग्जांपल है। तो ये जितने पैटर्न्स आपको बताए गए हैं, इन पैटर्न्स का आप इस्तेमाल कर सकते हैं अपनी फील्ड में। अब उस फील्ड में कैसे इनको इसको इंटीग्रेट करना है, इसके बेसिक को समझ के आप अकॉर्डिंगली इसको यूज कर पाएंगे। जैसे अगर आप मुझसे बोले
सर
जैसे मैंने लास्ट पैटर्न की बात की, सिमेट्रिक फिल्टर पैटर्न। तो आपके पास मान लीजिए कोई रिपोर्ट है, आपको उसमें से कुछ ऐसी इंफॉर्मेशन है जो आपको हटानी देनी है और आपको उसको मीनिंगफुल भी रखना है। तो इस समय आप वो रिपोर्ट उसको सप्लाई करिए, आप बोलिए कि इसमें सेंसिटिव इन्फॉर्मेशन हटा दीजिए, वो हटा देगा सेंसिटिव इन्फॉर्मेशन, और आपका डॉक्यूमेंट भी मीनिंगफुल रहेगा। इससे आपका टाइम भी बचेगा और आपकी एनर्जी भी बचेगी। इस तरीके से भी ये यूजफुल है। आप बताइए कि आपका और स्पेसिफिक आंसर, आपको स्पेसिफिक डिटेल क्या है।
हाँ सर, मेरा स्पेसिफिक डिटेल्स है, जैसे कि हम रिसर्च पेपर लिखते हैं सर, रिव्यू पेपर में भी तो हमें कुछ डायग्राम बनाना पड़ता है। जैसे कि
हाँ,
कुछ फ्लो डायग्राम हो या चार्ट्स रहते हैं गोल गोल, जैसे आपने यहाँ पे लिखा है ये टेबल जो है रेड ब्लू ग्रीन दिखा है, ठीक है ना सर। मान लीजिए
हाँ,
मैं एक मुझे जो चाहिए मैंने उस इमेज को लिया और उस इमेज को चैट जीपीटी में डाला और
हम्म,
बोला कि ये मेरा कंटेंट है, आप इस कंटेंट को इसमें डाल के आप मुझे इमेज दो।
हम्म,
ठीक है। तो जब इमेज देता है तो उस कंटेंट, वो जो राइटअप पार्ट होता है कंटेंट से बाहर चला जाता है। हम बार बार बोलते हैं उसे कि भाई तुम ये कंटेंट को उसका
ये
अंदर में लिख के दो, तो ये कौन सा परफॉर्मा होगा सर यहाँ पे?
देखिए, ये पैटर्न, ये प्रॉम्प्ट इंजीनियरिंग का पार्ट नहीं है। दिस इज नॉट द
ओके।
पार्ट ऑफ प्रॉम्प्ट इंजीनियरिंग, राइट? क्योंकि इसके पहले
ओके।
आपको ये समझना चाहिए कि एलएलएम काम कैसे करता है, क्योंकि 1 घंटे के लेक्चर में मैं आपको ये नहीं बता सकता कि एलएलएम काम कैसे करता है, और वो सबके लिए जरूरी
हाँ
भी नहीं है। एलएलएम जो काम करता है
हाँ।
वो बेसिकली बना है नेचुरल लैंग्वेज प्रोसेसिंग के लिए। वो उसको
हम्म
प्रिडिक्ट करना होता है नेक्स्ट वर्ड क्या होगा एक वर्ड के बाद, ठीक है? तो
हम्म
वो आपको
हम्म।
ये रिस्पॉन्सेस अच्छी तरीके से, इमेजेस के रिस्पॉन्सेज वो नहीं दे सकता, और ये प्रॉम्प्ट इंजीनियरिंग के अम्ब्रेला के अंदर ये चीजें नहीं आती। और अभी भी डेवलपमेंट बहुत बाकी है। जैसे जैसे टाइम प्रोग्रेस होगा, हो सकता है कि आपके डायग्राम्स वगैरह बनते रहे, पर डायग्राम के लिए अभी भी ये फीजिबल नहीं है।
डायग्राम इन द सेंस कि जैसे कि आपने ये फ्लो चार्ट या कुछ दिखाया है ना सर, तो
ये
उस
तो
फ्लो
पीपीटी।
चार्ट को मैंने लिया। अब पीपीटी
हाँ
में आपने तो कुछ भी फ्लो चार्ट दिखाते हैं ना,
हाँ
सर्कल
हाँ।
बना के हम पॉइंट्स बना देते हैं कि मेरा 5 चीज है, मैं 5 चीज दिखाना चाहता हूँ एक इमेज में, जो
हम्म
कि हम बेसिकली उसको हम पीपीटी में बनाते हैं सर। तो पीपीटी
हम्म
में बनाने के लिए टाइम लगेगा, मैं एक फॉर्मेट ले लिया, यहाँ पे डाल दिया और उसको कंटेंट दे दिया, तो
हम्म।
कंटेंट लेके वहां पे उसको हटा देगा और इसको डाल देगा।
वो आपको
तो ये
कंटेंट
क्यों
दे
नहीं कर
देगा।
रहा है मेरा? मेरा क्वेश्चन ये है कि वो तो हटा दिया, खाली कर दिया, उसको बोला मैंने उस फिगर से उस कंटेंट को हटा दे, तो वो हटा के
हम्म।
खाली कर दिया। और फिर जब मैंने बोला उससे कि मैं ये कंटेंट दे रहा हूँ, उस कंटेंट को उसमें डाल दे, ठीक है, और मुझे इमेज दे दे, तो क्यों नहीं दिया? जो दे रहा है बाहर जा रहा है, तो क्यों दे रहा है वो मुझे बताइए, वो मेरा यूजफुल है, इससे मैं ये सीख सकूं, आई थिंक, प्लीज।
ये ये पहली बात मेरे लेक्चर का पार्ट नहीं है, नंबर 1, कि इमेज वो दे रहा है, इमेज वो नहीं दे रहा है, क्योंकि
सर
इमेज देना।
सॉरी सॉरी डिस्टर्ब
हम्म,
किया।
हम्म।
एक्चुअली बेरा सर, व्हाट यू कैन डू, आप सिंपल उस चैट को डिलीट करके पहले से यूज कर सकते हो। चैट को ही
पूरा
डिलीट
चार्ट
कर
को?
दीजिए।
नहीं नहीं सर, मैं बोल रहा हूँ ना सर, कि जैसे ये एआई में क्या ऐसे कमांड दिया गया है, आपने जो प्रॉम्प्ट दिखाया मुझे, इतने सारे प्रॉम्प्ट हम यहाँ पे डिस्कस किए, इज आउट ऑफ दिस प्रॉम्प्ट, इज इट ये एप्लीकेबल है क्या इस इमेज और फिगर प्रोसेसिंग में, जैसे कि मुझे जानना चाहता हूँ।
नहीं, ऐसे कुछ ये नहीं है। वैसे देखिए, अगर फॉर एग्जांपल सर ने जो दिखाया वो है ये इजी वे ऑफ एक्सेसिंग ए लैंग्वेज मॉडल। आप
ओके।
लैंग्वेज मॉडल को कैसे अपने हिसाब से उसे ब्लेंड कर सकते हो, ये सर ने एक एग्जांपल लेकर दिखाया है। ठीक है ना सर? इसमें ये चैट जीपीटी इतना, चैट जीपीटी भी नहीं बोलूंगा मैं, ये एलएलएम इतना बड़ा है कि यू नीड टू वर्क एंड गेट यूर सेल्फ एक्सपर्टाइज इन दैट। ठीक है ना
यस सर।
सर? जितना
सर
आप
ये हमारा
चैट,
एरिया
ये
नहीं
भी
है
है एक और चीज
सर।
बता रहा हूँ कि जितना आप डिपेंडेंसी चैट जीपीटी पे बढ़ाएंगे उतना ही हम लोग का जो न्यूरोनल एक्टिविटी है इट विल रिड्यूस, बिकॉज वी विल बी एंटायरली डिपेंडेंट ऑन द एआई सिस्टम्स।
या यस
हाँ
सर, यस सर, एग्री सर, एग्री,
हाँ।
यस सर।
सो इज
बट
देयर
आवर
एनी,
टाइम विल बी सेव बस।
सो एनीबडी एल्स?
There is one question in chat box. K. Sri Devi. What could be the ethical challenges in this area?
আমি
व्हाट
ভাবছি
कुड।
অজিতের ওখানে আবার মেসেজ পাঠাবো যে অ্যাটলিস্ট
Hello,
শ্যাম্পুটা আর প্রোটিন প্যাকটা আমার চাই, এইরকম ওই প্রোটিন।
ma'am?
आई एम नॉट गेटिंग द लैंग्वेज।
Ma'am, can you speak again?
So I
I
want to make
think, sir.
again this session to be clear that this section is to give an introduction about prompt engineering. How you can blend a LLM model to do a specific work.
Yes.
Okay, it can be anything. It can be protein. It can
Application
be
can be
image.
anything. Yes.
I can tell you one example. For example,
सर सॉरी
in
टू डिस्टर्ब
US,
यू सर। सर सॉरी टू डिस्टर्ब यू। सर
हाँ,
एलएलएम मॉडल क्या होता है पहले वो क्लियर कर दीजिए, वो क्लियर हमें नहीं है, बिकॉज आई एम नॉट फ्रॉम दैट एरिया। अगर वो आप क्लियर कर देंगे ना सर, तो आगे मैं समझ सकूंगा, प्लीज सर।
Sumi sir,
देखिए,
please.
बहुत बहुत आसान शब्दों में आप एक बात को ये समझिए कि लार्ज लैंग्वेज मॉडल क्या है। एक ऐसा एआई का क्रिएशन है ना, जो कि बहुत वास्ट डेटा पे, बहुत ही ह्यूज डेटा पे ट्रेंड है, ठीक है? और इसको इंटरेक्टिव बनाया गया है इस सेंस में कि जैसे आप एक किसी दोस्त से बात करते हैं, किसी प्रोफेसर से बात करते हैं, ठीक उसी तरीके से आप इससे बात करके आंसर्स को निकाल सकें। ये बहुत ही सिंपल टर्म्स है। अब मैं टेक्निकलिटी में जाऊंगा कि कैसे काम करता है, वो करता है, तो वो हो सकता है कि आपके समझ से बाहर हो जाए। तो ये जो आज जो सरल शब्दों में हम मैंने बताया वो आपको ये। दूसरी बात ये कि एलएलएम्स आर नॉट गॉड, वो भगवान नहीं है कि आप उनसे कुछ भी करवा सको। ठीक है, वो जिस चीज के लिए बेसिकली एलएलएम जो अभी कैपेबल है वो नेचुरल लैंग्वेज प्रोसेसिंग के लिए कैपेबल है, और हम उसको ट्यून कर रहे हैं इमेजेस के लिए। फॉर एग्जांपल डॉली वगैरह जैसे टूल्स हैं, और वो भी प्रॉम्प्ट के थ्रू अभी भी वो लेवल के रिस्पॉन्सेज नहीं है जो हमें मिलने चाहिए। ठीक है, तो नेचुरल लैंग्वेज के आसपास आप जितना भी काम कर सकते हैं आपको वो काम इस समय बेहतर मिलेगा। इसीलिए मैंने रिस्ट्रिक्ट किया अपने लेक्चर को नेचुरल लैंग्वेज के ही अराउंड। और इन सारी चीजों को आप केवल बायोमेडिकल ही नहीं, आप अपने नॉर्मल लाइफ में भी आप यूज कर सकते हैं, जो भी काम आप अपने प्रोफेशन में करते हैं।
सर टू स्पेसिफाई दैट, जैसे आप गूगल यूज करते हो, गूगल हो गया, सर्च इंजन कोई भी हो गया, ठीक है ना सर, आप उसे यूज
कौन सा
करके क्या
मॉडल?
पूछते हो, कोई भी क्वेश्चंस पूछते हो ना, सेम वे में एलएलएम मॉडल एक ऐसे चीज है, उसमें हम लोग क्वेश्चन ड्रॉप करेंगे, क्वेश्चन एक ड्रॉप करेंगे, वो उसका आंसर देता है।
तो
ठीक है
सर
ना सर?
LLM is the chat GPT is also LLM?
हाँ हाँ हाँ, इट इज ऑन, इट इज
चैट
ऑन।
जीपीटी, इट इज एलएलएम।
हाँ,
हाँ
या जो कोलपाल, जो जेमिनी, these are different types of LLM, right?
एलएलएम,
If
यस
I'm not
यस
wrong.
यस यस, यू आर
Yeah,
राइट,
yeah.
यू आर राइट।
एक्चुअली
So
देखिए,
they
चैट जीपीटी एक कंपनी का है,
ओपन
और
एआई,
maybe
जेमिनी
sir.
इट इज लाइक माइक्रोसॉफ्ट, राइट सर?
गूगल,
Yes sir, yes sir. Yes sir.
गूगल का है।
हाँ,
हाँ
हाँ
फाइन,
हाँ।
और एक और है, अभी नया भी आ रहा है ना,
परप्लेक्सिटी है, क्लॉड है,
परप्लेक्सिटी।
क्लॉड
परप्लेक्सिटी
है,
एक्चुअली अच्छा है करके बोल रहे हैं, पर उसको, उसका पैसा ज्यादा है, जितना
हाँ,
मुझे पता। तो एक्चुअली दीज आर
मेटा है।
लाइक, ये क्या है ना, जो इंटरनेट में जो डाटा अवेलेबल है ना, जो बल्क डाटा जो इंटरनेट में अवेलेबल है, दे यूज टू, क्या बोलते हैं, ये एलएलएम मॉडल इज बीन ट्राइंड यूजिंग दैट डाटा विच आर अवेलेबल ऑनलाइन। ठीक है ना सर? एलएलएम
अच्छा।
ऐसे मॉडल है जो इट हैज बीन ट्राइंड यूजिंग द डाटा विच आर अवेलेबल इन द इंटरनेट। बस उसमें से हमें चाहिए जो चाहता है, हम कुछ देंगे प्रॉम्प्ट में, तो इट विल आंसर बाय रीडिंग, बाय वॉट एवर इट हैज बीन स्टोर्ड, राइट, उसके मेमोरी में जो भी है, सो इट विल ट्राई टू डिलीवर यू आउट। इट मे बी ट्रू, इट मे बी करेक्ट, और इट मे बी रॉन्ग, बट वो आंसर देगा, कुछ भी उठा के
यस।
देगा।
हाँ
राइट
श्योर।
सर?
यस सर, श्योर श्योर सर। वो तो हमें डिसाइड करना वो सही दिया या नहीं दिया है।
हाँ, it is
या
like everything
या
is because it is been
या
created by
बट बट बट
human, not by the
बट
God.
yes sir, yeah sir, that is human, but if you'll see, it will make the person's work easier. It will lessen the time. अगर हमें एक काम करना पड़ रहा है सारा दिन 6 घंटा, तो ये हमें समरी दे देता है। कोई भी चीज का हम अगर मांगू तो तुरंत ही दे देगा, तो इतना घंटा प्रिपेयर नहीं करना पड़ता। उस कंटेंट में हम बात कर
हाँ,
सकते हैं, कहीं में
हाँ,
इमरजेंसी में कुछ भी कर सकते हैं,
हाँ,
आई
तो आप
बिलीव।
आप लास्ट एग्जांपल को रेफर करिए जो मैंने दिया। एक रिपोर्ट से अगर आपको सेंसिटिव इन्फॉर्मेशन हाइड करनी है, उसकी मीनिंग भी आपकी वो मीनिंगफुल भी रहे, तो उस केस में आप ये इसका इस्तेमाल करेंगे, तो ये कुछ मिनटों का खेल है। अदरवाइज आप पूरे डॉक्यूमेंट को लेके बैठेंगे, उसको रिफ्रेम करेंगे, आप नाम हटाएंगे, एज हटाएंगे, ग्रामर को एडजस्ट करेंगे। ठीक है, इस काम को वो तो कुछ मिनटों में करके दे देगा। तो आपकी बात देखिए सही है, आपका बहुत टाइम सेव होगा उससे।
सब पर
या
बात है,
दैट।
अगर आप ये सब एलएलएम मॉडल यूज करेंगे ना सर, देन यूर इंटेलेक्चुअलिटी, जैसे
इट
आपका
विल,
व्यू रहेगा, एक इमेज मुझे ऐसे बनाना है, एवरीथिंग विल फेड आउट। ठीक है ना सर? जो आपका जो ये है, क्या बोलते हैं उसका नाम, इंटेलेक्चुअलिटी, वो धीरे धीरे डिग्रेड हो जाना है, होने लगेगा। सो इट इज बेटर दैट वी शुड लेस डिपेंडेंट ऑन एलएलएम मॉडल,
नो नो सर,
बिकॉज
यू आर राइट सर, यू आर
हाँ
राइट सर, यू आर राइट। देखिए सर, हर किसी के पास आर्ट वाला, ड्राइंग वाला या चीज नहीं रहता है। जब अभी सारे चीज पैसे पेड होते हैं सर। आप बताओ, बायोरेंडर में जाओगे तो पैसे मांगेगा कि भैया आप एक्सेस करना है, तो फ्री में नहीं करेंगे, अब पैसे दे दो, आप कर लो। तो यार हमें तो कुछ अपने वे में तो निकालना है कि कैसे हम कैसे काम को हासिल करें। तो आई थिंक दैट्स व्हाट वी आर यूजिंग, और नथिंग एल्स। करना तो कर लेंगे इंसान, टाइम लगेगा, आज नहीं तो 5 दिन।
Okay, sir. I think that answered your question, all the queries that you had. Ashok
Thank you,
sir.
sir. Thank you very much. Thank you very much,
Thank you,
sir.
sir, for
Nice
answering that
interaction.
beautifully.
Sir,
Bhubaneswar
we are
also.
running out the time. Ma'am,
Yes,
please.
our next next speaker has joined also. So
So can I?
I'll take a few moments to thank our first speaker, Dr. Sumit. So, sir, it was
Thank
a
you.
very enlightening session. Kindly accept digital memento on our behalf, on the behalf of organizing team. Thank you so much for this wonderful session.
Welcome. Welcome.
So thanks for your time.
Thank you, sir.
Welcome. Shall I leave?
Sir,
Yes,
yes,
sir.
sir.
Yes.
Yes, sir. Thank you, sir.
Welcome.
Thank you, sir, for your wonderful talk.
If you
And
want to join, you can join, sir.
yes, sir, if you want to stay here,
Dr. Sanjay
listen
Saxena
to the
sir
further
will
talks, you
deliver
can
their talk.
definitely
So
yes.
if you have
Actually,
time, you can be in the meeting, sir.
oh no,
Yes.
I would love to join, but I have a class from 12, so I have to prepare for that. So thanks a lot. Thanks a lot.
Okay. Thank you.
Okay.
Okay, sir. Okay.
Okay. Bye.
Thank you, sir.
Bye.
Bye. Sir. Okay, so moving ahead, we now invite our second speaker of today's session, Dr. Sanjay Saxena. Hello. Sir, kindly mute other participants. Okay, so I now invite Dr. Sanjay Saxena from Triple IT Bhubaneswar, who will be delivering his lecture on role of AI in radiogenomics-based study of brain cancer. Dr. Saxena is an accomplished assistant professor in the Department of Computer Science and Engineering at Triple IT Bhubaneswar, Odisha, India, with a PhD from IIT BHU and postdoc research at University of Pennsylvania. His work focuses on the intersection of artificial intelligence and healthcare. Dr. Saxena specializes in applying AI, machine learning, and deep learning to advance cancer diagnosis and treatment, particularly brain tumors. As the CEO of RIPITT, Research Innovation Projects, Incubation and Technology Transfer Foundation, he leads initiatives in research, innovation, and technology transfer. He is also at the forefront of developing AI-based methods for healthcare at IIIT Bhubaneswar and actively contributes to fostering interdisciplinary research. His notable academic contributions include numerous presentations and publications on AI applications in medical imaging and radiogenomics. Beyond his academic pursuits, Dr. Saxena is passionate about mentoring young researchers and collaborating on projects that drive technological advancement in healthcare. Dr. Saxena has published many research papers in high impact research journals and various conferences. So, this session by Dr. Saxena promises to uncover the intersection of AI and genomics in the context of brain cancer diagnostics. Welcome, Dr. Saxena. The platform is yours.
Thank you, Dr. Anjali, Dr. Gaurav, and Dr. Yunesh for inviting me. And it was very huge introduction. So already we are running out of time. So, anyways, thanks for inviting me. And it will be great to discuss the new technology based on AI based methods on radiogenomics studies of brain cancer in front of you all. So it will be great if this session will be interactive. People can ask as much as question, so that I'll be happy to deliver the answer. So without wasting my time, I will like to start my presentation. So let me know whether my screen is visible to all of you or not. 1 minute.
Sir, you can share your screen.
Yes, I'm just
Yes.
sharing.
And sir, we have sufficient time. You can take beyond 1 hour, sir.
No, I'm having some
No
other
need to
commitments.
rush.
Okay.
I'm having some other commitments as well. So I will try to finish within 1 hour,
Okay.
and maybe I will take a couple of more minutes. Anyways,
Thank you, sir.
so let me start my presentation. So my screen is visible or not?
Yes, sir.
Yes, sir. Yes, sir.
Okay,
Yes.
great. Thanks, Dr. Gaurav and
Sir,
Anjali. So,
please keep it in full screen mode, sir.
sure, sure. I am doing that.
Right. Yeah.
So today I'll be discussing about role of artificial intelligence in radiogenomics studies of brain cancer. So we all know that we are living in the era of artificial intelligence. Everywhere is there is artificial intelligence, from our mobile to healthcare. I mean, satellite imaging, we are driving the car. So everywhere there is a artificial intelligence. So we are living in the era of artificial intelligence. So I'll be discussing about what is the role of AI in radiogenomics. Radiogenomics is a kind of a new, not I can say the new technology or word. It is a couple of, 4 to 5 years ago, before it is started, and many of the researchers around the globe are working in the area of radiogenomics. So I will try to give the brief introduction from the basic up to the advanced implementation of radiogenomics for brain cancer, and how we can apply artificial intelligence based method in radiogenomics study of brain cancer, that I'll be discussing. So this is about the points of discussion in today's talk. I will be discussing about firstly about the radiomics. What will be what is the radiomics general flow? There are various imaging features. Specifically, I will be discussing about texture features in brief, and exactly what is radiogenomics, which is the combination of radiomics and genomics. I'll be discussing about artificial intelligence, basic, not in the detail. I'll be discussing about the basics of AI, ML, and DL, how AI in radiology in the area of precision medicine played a very important role. Various statistics of radiogenomics, neural network, and CNN in brief. At the end, not at the end, in the middle of the presentation, I'll be discussing about various case studies that will show how AI-based method are very useful for radiogenomics-based study of brain cancer. So this is the points of discussion that I will be discussing today. So first of all, we should understand what is radiomics. So what is radiomics is, radiomics is a method that extracts many quantitative features from the medical images using various data characterization algorithms. So this is the definition. So what happens? Patients go for the examinations. So like patient can go with a CT scan, PT scan, and MRI scan. Then as you can see in the figure, that patient, suppose a patient is suffering from certain kind of a cancer or certain kind of disease, so he or she will go for the various kind of examination like CT, PT, and MRI. And the next step is image segmentation. For what is image segmentation? Image segmentation is the process of partitioning an image into its constituent regions. So this is the pre-processing step. So image segmentation basically important to highlight a particular region of interest. Okay, so it can be in the 2D or it can be in the 3D. Now radiomics comes into the pictures. So radiomics is nothing but a quantitative feature extraction from various kind of medical images. So features could be like shape features, it could be like intensity based feature, it could be texture based features, or it can be any kind of a filtering based method as well. So after getting the quantitative features, then we basically go for the data analysis. So data analysis can be will be having like feature uh, engineering, like feature selection, and so on. And we can develop the models, and ultimately this process will go towards the therapy and the prognosis side, and then we basically make the decision support system of diagnosis. So what is the take home point here? Radiomics is a method that extract quantitative features from the medical images. Okay, so ultimately the goal is we have to play with the features that we are going to extract from the images. So this is radiomics. And this is the flow that shows the radiomics extraction, traditional and deep traditional machine learning based methods for radiomics features extraction or deep features. So as you can see in this flow, there are a couple of images like MRI scan, CT scan, PT scan, X-rays, and CTPT, and this X-rays and CT. So as I discussed in the previous slide, the second step is basically based on the image segmentation, which is basically partitioning an image into its constituent regions. As you can see that the region of interest here is the tumor. So like here, this is the region of interest, and so on in the abdomen region. So this is the basically the region of interest using the any kind of image segmentation based algorithm. Now we can go with the traditional feature. Radiomics can be divided into two types: traditional feature extraction and the deep feature extraction. This is basically this is showing the traditional feature extraction, that is having like geometric features, it could be texture based features, it could be histogram based features. Then traditional features basically will go towards the data analysis part. So it can have the model implementation, feature engineering, and so on, and we can have some statistical analysis as well. So this is traditional radiomics. Now I'm coming towards the deep radiomics. In deep radiomics, what happens, we have, I mean, if we are using the implementation of any convolutional neural network, or we are applying any kind of a transfer learning based methods of existing pre-trained models, so basically we are extracting the deep features. Okay, so deep features are very important when we don't know about which kind of the features that a particular image has. So at that time, deep features are very important. So in general, what we can say that uh, if we don't know about which kind of features a particular image can have, then it's better to go with the deep features. So deep features are very useful to extract the minute information from the images. Okay, so we can have a small filters like in convolutional neural network, or we can have some transformers, I mean vision transformers there, vision transformers are there, so we can extract the minute features from the images. In case of medical imaging, it's better to have a deep features, because in certain diseases, specifically like in brain cancer or in any kind of a cancer, so cancers are very heterogeneous in nature, so we cannot predict the which kind of features that a cancer has. So it's better to go with the deep features. So this is deep radiomics. So ultimately the take home point here is radiomics can be divided into traditional machine learning based features like geometric features, texture feature, histogram based features, or it can have a deep radiomics. Now I'm coming towards what is radiogenomics. As its name suggests, radiomics is equal to radiomics plus genomics. So we understood about radiomics. What is radiomics? It is the quantitative features extraction. I mean, quantitative features extraction from the medical images. That is radiomics. Now genomics, its name sounds like we have to play with the genes. Okay, so in general we can say that what is radiogenomics? It is an approach that combines large volumes of radiomic features from medical digital imaging, genetic data from high throughput sequencing, and the clinical data into the mathematical modeling. So that is a definition of uh, radiogenomics. So ultimately we will be adding radiomics along with the genetic data for a certain disease or certain human tissues. Okay, either we can use radiomics plus genomics for some kind of a clinical predictions or some kind of a clinical interventions, or we can have some relationship between radiomics with the genomics or genomics with the radiomics as well. Okay, so this is a general overflow. Radiomics is equal to radiomics plus genomics. Like these are the several steps. This is a general flow. First of all, the data acquisitions and pre-processing. There will be a feature extraction and selection, association of radiomics and genomics, data analysis, and the outcomes. Like here, you can see that there is a radiomics data, as we discussed in the earlier slides, like extraction of quantitative features using medical images. So these are the medical images, and then we have to extract the region of interest. Here the genomics data we can consider mutation data present in a certain kind of disease or human tissues. So here you can see in the second block the phenotypes are there, like geometric features, texture features, statistical feature, value based features. Those are coming from the medical images. And if we talk about the genotype, there are certain mutations like IDH mutations, TP53, MGMT. These are basically specific to the brain cancer based uh, biomarkers or mutations. So these are the genetic information that we are getting from the like sequencing, and these are the information that I mean these features, geometric, texture, or statistical features, wavelet features, these are coming from the medical images. So ultimately what we are doing in this third block, we are merging with the phenotypical information with the genotype information. Okay, so this is a radiogenomic profile. Then we are going towards the data analysis thing, like deep model. We can build the deep model, we can have any machine learning based models like SVM, we can have random forest and so on. We can have different statistical evaluation based parameters, or we can have various heat maps. Then ultimately we can go with the any kind of outcome like survival predictions. We can give the tumor grading. We can find out any important kind of imaging biomarkers. It can be used for the clinical decision. It can be used in the precision medicine. We can find out the risk stratification, and then we can develop any kind of a treatment selection based method. So this is the general flow that starts from data acquisition and pre-processing to the outcome. So in the middle of the block, the radiogenomics plays a very important role. Okay. So this is about the general flow of radiogenomics. Now I'm coming towards the studies, like in the current scenario, like we know that the US and China plays a very important role in kind of any kind of new technology based research in the healthcare. So as usual, 39%, this is a basically representation of the country wise distribution of the radiogenomics studies in the current scenario. Like 39% of the studies are done from USA only, 31% from China, and a couple of more countries those are working like Japan, Germany, South Korea, Taiwan, and so on. So these are having a very small percentage comparative to the United States and the China. And in India, a couple of groups, like including my group and some other group in India, they are working in the area of radiogenomics based study of brain cancer specifically. Okay, so this is the country-wise distribution of radiogenomics studies. And AI used in the radiogenomics studies, like many of the people, many of the groups around the globe, they are using artificial intelligence in radiogenomics studies. If we are classifying, if we are categorizing those things, so 57% studies are based on the machine learning, 33% studies are based on deep learning, and 4% of the studies both uses, ML and DL. And there are a couple of studies they are not using any kind of machine learning and deep learning. Those studies are basically based on the statistical based analysis. So majority of we can see from this pie plot that the majority of the studies they are using either machine learning, deep learning, or both. So if we categorizing, if we see this plot, like majority of the studies they are using CNN, then regression, then random forest, and you can see that the majority of the studies based on the CNN only, because medical CNN basically it is a general term. CNN it is written, it is basically deep learning based model. It is also including the transfer learning like pre-trained model as well. So in general, people are using the deep learning based model, specifically CNN, because of it is very difficult to find out the specific features from the medical images. So this is the trend of using AI models in the radiogenomics studies of uh, cancer. So this plot is showing the image modalities of radiogenomics studies. Like 45% of the studies are based on the MRI, 39% studies are based on CT scan, 8% studies are based on the CT and PT, and very few study are based on the PT scan, MRI, CT, and the PET scan. So majority of the studies are radiogenomics based studies are the MRI and CT, because of these modalities uh, uh, gives the detailed information of the human tissues, like in terms of sagittal information, frontal information, and the axial information. So that is the reason the people are using the MRI CT scan more. So let me give you the brief introduction. What is the difference between machine learning and deep learning? Machine learning basically, the whole process is divided into, majorly it is divided into two sections: feature extraction and the classification. The programmer or data scientist or AI engineer knows which kind of feature that he or she is going to extract from the image. As you can see here, like these are the trees. uh, this programmer knows which kind of features that he or she is going to extract. Then the features is passed through the classification based system, and then this classification based system can classify these input images are tree or not. In case of deep learning, it is a basically combination of the feature extraction and the classification in the one go. The features will be extracted and the classification is done. So that's why it is deep learning is important for handling the medical images, because of the less I mean, the medical images or human tissues are highly heterogeneous in nature, so that depends on the patient to patient wise. So the general difference is this, like obviously yes, we can have some feature extraction step here in this deep learning as well. I mean, we can segregate this feature extraction and the classification steps in the deep learning as well. So this is the difference between the machine learning and deep learning. I know that couple of many of you know what is the difference between these, but in terms of the medical images or in terms of the any kind of cancer analysis, this plays a very important role, because sometimes deep features gives a more appropriate information instead of the machine learning. So these are the various imaging features. If we are going towards extracting the imaging features, like based on the machine learning, we can have, I'm not going into the details of the each and every features because it will take too much time. So we can have the shape based features, we can have intensity statistics, we can have gray level co-occurrence matrix. This is gray level co-occurrence matrix, gray level run length matrix, and gray level size zone matrix. These are very important for getting the information texture wise from the image. So these are the various imaging features that we can extract uh, uh, from the medical images to build a classification on regression based models. So very famous texture features for medical imaging, because in medical images, texture plays a very important role. So texture analysis is very important. So for, as I discussed, like for analyzing the texture from the conventional radiomics, there are GLCM, GLRLM, and GLSZM based method. So this is the general structure how we compute the gray level co-occurrence matrix. Basically, gray level co-occurrence matrix identifies how two pixels are related in the horizontal direction, or in 45-degree, or in 90-degree, or in 135-degree. So as you can see, this is the 4x4 image, like two two zeros pixels are adjacent to each other in the 0-degree direction. So we can have this frequency in the next in this matrix. Like here you can see that this is two zeros, both are situated in the 0-degree directions, like here and here, so count is 2, so we can place it 2. So similarly, we have to build this matrix that is called gray level co-occurrence matrix, and basically it identifies how the pixels are present in the neighborhood of each other. So this is gray level co-occurrence matrix. Based on that, we can have the normalized GLCM, and then we can go further for the texture analysis by extracting any kind of GLCM based features, like energy, entropy, and so on. So this is the general architecture of deep learning based convolutional neural network. In convolutional neural network, it is divided into a two-section: convolution plus neural network. Neural network is used for classification or regression based purposes, and convolution is a mathematical operation that I will discuss in the next slide. So convolution is mathematical operation to extract the minute features from the image. So this convolutional neural network consists of various kind of layers, like convolution layers, followed by pooling layer, and activation function layer, and so on. So this is the input image. First of all, what we have to do, we have to, for the convolution operation, we have to pass this image with a certain kind of filters. Filters are nothing but a small matrix to extract various kind of features maps. So from the images, from the input image, we can have a various feature map by using the convolution based filters. Then after creating the features map, we can have the pooling layer. What is the role of the pooling layer? It reduces the dimension of the feature map. Okay, so then we can have the pooled features map. Then again we can have convolution layer, to extract various other features map. Then we can have the pool features map. Then we have to flatten the whatever the features map that we are getting here. Then we can flatten the features map, and then we will pass this flattened vectorized features maps into the neural network. This is basically the fully connected layer to classify. Suppose we are classifying this tumor is of type tumor grade 1 or tumor grade 2, we can classify it here. So this is the general architecture of convolutional neural network. We have to pass the image. That image uh, will be going through various layers, including convolution layer, activation function layer, and pooling layer. At the end, this will be classified as a certain kind of clinical protocols. So this is the convolution operation. These are the 3D images, and these are the small filters that we have to pass through these images. So it will be multiplied by, I mean, this filters values will be multiplied by the image pixel values, and the middle values will be replaced by the summation whatever that we are getting here. So this is the example of how convolution operation works. So in general, what we can see that here is, this is a image of a dog and this is a cat. We are passing it here input. There are a couple of hidden layers, and we can classify whether it is a dog or it is a cat. These are the feed-forward neural network to classify, like for it is used for the classification. The input layer will be there, like whatever the we are getting in the CNN and the flattened layer, we have to pass it here. Then there could be a single hidden layer, or it could be a multiple hidden layers, and it can be classified in the into the different kind of output. Now, I'm coming towards another important concept that we can use here is transfer learning. What is transfer learning? At its name suggests, we are transferring the learning. Okay. So what happens in healthcare, specifically in the brain cancer or in any kind of a cancer, the data is limited. Okay. And we know that machine learning based model or deep learning based model or any AI model basically plays with the data. If we are having the more data, our accuracy will be more. Okay, we can build a more robust and more generalized model. So the data is less, so the training will be difficult. So it's better if any model is trained on some other data, and we can use that knowledge in our healthcare data, so that can make a good impact. I mean, that can make a significant, that can go towards the significant results. So transfer learning, like as you can see in the figure, the task one, the model one is trained on data one, and the predictions is there. So we can have already the model is trained here, then we can have the knowledge transfer for the task two. Suppose if we are doing the uh, uh, brain cancer prediction or any kind of a disease prediction, then we can use this trained model. We can transfer this knowledge here to our task, and we can have the predictions. Okay, like couple of models like ResNet, AlexNet, VGGNet, all these kind of models are trained on the ImageNet data set. ImageNet data set is having a millions of images. So these models are trained on those data set, and we can use that models as a transfer learning for our healthcare based analysis. I'm not saying this is very always this will give a good result, but uh, it can up to some extent we this can lead us to significant results. So this is about the transfer learning concepts, and this is the general flow: artificial intelligence, machine learning, and deep learning. Artificial intelligence, we all know that the program systems to perform tasks which normally requires human intelligence. Machine learning is the subset of artificial intelligence, and deep learning is the subset of machine learning. Deep learning basically it is basically a network that is having a different kind of layers. Okay, and this whole set can be used for the oncology healthcare, for the precision oncology, drug discovery, imaging, and digital pathology, next generation sequencing, and the patient data management. So if we talk about the AI in radiology, so it is basically, it moves from the clinical protocol selection to the treatment prognosis. It's in each and every steps, like from clinical protocol selection, image acquisition, image reconstructions, processing, visualization, analytics, lesion detection, CAD diagnosis, and the treatment progresses in each and every steps. AI can be fitted and it can be used significantly. So, so this is the general what we have covered till now. What is radiogenomics? Uh, and also we have seen the important concept related to the features extraction, CNN, and how people are using the radiogenomics system. Now I'll be discussing some specific case studies of my group that will show how these how AI based method can be implemented in the radiogenomics based studies of brain cancer. So the first study that I'll be discussing about artificial intelligence and MRI based method to capture regional heterogeneity and its association with overall survival of GBM patients, perspective on NGMT methylation. So there are a couple of biological terms. So let me give you a brief introduction about this. So what is glioblastoma? Which is it is basically a malignant and dangerous type of a brain tumor. The median survival rate is 15 to 16 months, which is unpredictable because of the highly heterogeneous behavior. So glioblastoma is a malignant and dangerous type of a brain tumor. So multiparametric MRI scan T1, T2 flare and T1 GD are the reliable way to visualize GBM. There are a couple of more functional MRIs also to visualize the brain cancer or glioblastoma specifically. But T1, T2 flare and T1 GD are the reliable way to. These are the basically structural modalities. This will give you the detailed information of about the glioblastoma. So this is about the glioblastoma, which is shortly called as GBM. And there is another concept that is called as O6-methylguanine methyltransferase. Shortly, it is called as MGMT. What is MGMT? Basically, it is an enzyme that repairs damaged cells. So what happens when chemotherapy kills cells? MGMT basically fixes them. So if a patient is suffering from, let me give you a brief scenario. If the patient is suffering from glioblastoma and after biopsy the doctors find out that patient is having MGMT, that it shows that it will lead towards the prolonged survival. Okay, so it is associated with an improved response to the chemotherapy with the temozolomide, and it leads towards the longer overall survival. So if the MGMT is there, then the patient could go towards the for the longer overall survival. So how the doctors identifies the MGMT? The invasive biopsy is the only way of MGMT methylation determination in current clinical practice. So there are two things that we have seen. GBM, that is one thing. Another thing is MGMT. So GBM is the highly dangerous type of a brain tumor. Survival is unpredictable because of the heterogeneous behavior. And MGMT, it is an enzyme that repairs damaged cells. So if if the patient is having MGMT, then it leads towards a longer survivals. And how the doctors identify the MGMT methylation? Using invasive biopsy based method. So in this research, the objective was to develop a reliable non-invasive way to determine MGMT methylation using machine learning and MRI based protocols. Also, the objective and motivation was to capture spatial heterogeneity perspective to MGMT methylation in GBM patient. Also, we wanted to identify the relationship between MGMT methylation with the overall survival of the patient. So, keeping these three main objective and motivation in our mind, we have started this work. So before going to the entire pipeline, I would give you the general structure idea. Like these are the structural MRI brain scans. This is T1 scan, this is T2 scan, this is flare and T1 GD. As you can see here, all are having different phenotypical characteristics here. And this is basically this red, blue, and green region. This entire thing is representing it as a glioblastoma with different sub-regions. Like this red region is tumor core, this blue region is the enhancing tumor region, and the green region is nothing but the edema, that is the swelling part. So the entire thing is basically the whole tumor, okay, which is which is having three sub-regions like tumor core, edema regions, and the enhancing tumor regions. So this was the general flow of the work. So we have started with these different four modalities. So instead of going through the entire region at the time, what we did, we just extracted different patches. The reason of extracting different small patches to get the to get the minute information from the tumor regions. So we have extracted the features from the T1 image, from the T2 flare and T1 GD. So we created the discovery cohort, which is a pool of patches. Then we did then we have implemented the ensemble deep learning based model. I will discuss about the model in the next slides. So we have created an ensemble deep learning model to identify the MGMT methylation, yes or no, and then we created the model. Then for the replication, again, we did this thing for the replication cohort for the independent testing. We created the pool of patches, then we have computed the accuracy. After getting this after getting this train model, we created the heterogeneity map. Heterogeneity map, basically we have defined on the pixel wise MGMT methylation percentage. So basically we have identified uh, a, we have identified a pixel is present in how many correctly classified patches. So based on that, we have created the heterogeneity map, and then we have computed the heterogeneity index. Heterogeneity index is nothing but the coefficient of variation that we have computed here. After getting this heterogeneity map, we move towards the conventional radiomics analysis. Like we have extracted a couple of more features, like these are the machine learning based features. Then we created a model, and then we have found out the survival index. So this is the whole flow. So you must be thinking, where where is the radiogenomics thing here? So radiomics, basically we are dealing with all these images by extracting different features and training the model. We are playing with the radiomics thing. And what was the end goal? End goal was the MGMT methylation. That basically we are dealing with the genetic informations. So this is the entire flow, and these are the results that we obtained when we computed the MGMT, heterogeneity map for MGMT methylated patient. As you can see that the entire region shows the red regions, like it shows that there is MGMT methylation. Like red is showing, basically it is the relative high methylation, blue is the relatively low MGMT methylation. And these figure, the top figure, as you can see that this is generally it is showing the blue region that shows a relatively low MGMT methylation. So what is the important finding that we got here? We have like our model was able to, somehow what is able to classify MGMT methylated and unmethylated patients. So what happens, uh, obviously the accuracy for the prediction was 0.82. So we were focused on what about the 18%. So when we created the heterogeneity map of the incorrectly classified patient, then we have observed a very important characteristics, like the heterogeneity maps are showing the non-uniform pattern of MGMT methylation. So it means our model was able to recognize the MGMT methylation patient and MGMT non-methylated patient, but our model was not able to recognize the heterogeneous patients. So the incorrectly classified patients are the heterogeneous based patient, and we have confirmed this with the biopsy results as well. So this is the heterogeneity indexes we have computed based on the coefficient of variation, MGMT methylation, and for MGMT unmethylated, it was very low. For the incorrectly classified patient, the heterogeneity index was very high. And the relationship between the survival index and the overall survival, this is quite, not, I will say that very very significant in terms of accuracy, but it is very promising. It shows a very good correlation, like 0.70% Pearson correlation coefficient that we obtained here. Like it shows the MGMT, somehow it is related to the survival of the patient. So this major contribution of this work was to create the ensemble deep learning model. So we have created a different CNN model based on different kind of patches. We did the pixel wise MGMT methylation computation, then we did the final estimation here. Instead of training a single model, we have trained a couple of models to find out the minute information from the images. Then after creating the heterogeneity maps, we did the conventional ML based feature classification scheme to find out the survival index. So this is one case studies that shows how imaging are related with the MGMT methylation by implementing various ML and DL based methods. Another case study that I will be discussing about the overall survival and MGMT promoter methylation estimation. In this study, that we have considered again these four modalities. We have extracted conventional radiomics based features. We have extracted the deep radiomics based feature using various pre-trained models like ResNet, VGG16 and VGG19. So that's why I wanted to point it out here. Like these ResNet, VGG16 and VGG19, these are very quite old model. These are trained with the ImageNet dataset, but somehow these results, I mean, the knowledge of these models, somehow these are contributing in the medical side, I mean, for the classification purposes in for the brain cancer patients. So conventional radiomic based features we have extracted the deep radiomic based features. So from these model ResNet, VGG16 and 19, then we have fused that features. Then this fused version of features went through regress feature selection based method, like we have implemented the variance of, I mean, remove the low variance based feature, we did the recursive feature elimination, and then we did the survival prediction and the MGMT status prediction of the patient suffering from glioblastoma. So somehow the accuracy was for MGMT AUC is around 0.76 with the confidence in 95% confidence interval from 0.70 to 80. And also we have obtained a very important, I mean, significant cohesity effect size of around 0.73. So somehow that indicate, somehow the main important key crux of this work was like deep features from the pre-trained models played a very important role while dealing with the healthcare based analysis. So this is about the case study 2. Another case study 3, the clinical measure radiomics and genomics offer a synergistic value in AI based prediction of overall survival in patient with glioblastoma. Again, what we did here, instead of using only MGMT, we have considered a couple of more genomics based information like different other mutations like EGFR, TP53 and so on. Also, we have considered the radiomics like medical imaging based features. So this is basically two stages process. This was the basically two-stage process. Stage 1, model training for radiomic signatures. Here in stage 1, we have extracted the features from the radiomic side, and then in stage 2, we did multi-omics stratification, is considering the radiomics, MGMT methylation, other genomics information. We have also considered the resection status, demographic, specifically age and gender, other clinical measures, and then we trained a Cox regression model, and we did the risk stratification. So this was the model that we have trained for the developing the radiomic signature like T1, T2 flare and T1GD, I mean T1C. We have considered here. Again, we have considered different patches considering covering the whole tumor. We have trained two classifier for the patient less 6 months versus all, and another classifier for patient less than 18 versus all. We have computed the pseudo probability by fitting a SVM model, and then we have computed the SPI radiomics by averaging the pseudo probability that we are getting here. Also, we have extracted the features from the VGG19 architecture. So this flow is basically showing the model training for the radiomics based signature. So this is the survival prediction index and the selected features. As you can see in the top figure, like this is high risk for the training, high risk for the independent. This is the blocks, or I mean box plot for the medium risk for the training, medium risk for the independent, this is for the low risk, and so on. The important point here, you can see that when we have computed the feature importance plot here, so in this you can see that many of the features are from deep and many of the features are from the machine learning based features. So we have to, I mean, we have to have the faith on the deep learning as well as for the machine learning for such kind of analysis. Blindly we cannot go with the deep learning, or blindly we cannot go with the machine learning. Somehow the information are preserved in the machine learning side as well as in the deep learning side. These are the Kaplan-Meier curve that we have drawn for indicating the synergistic effect of various important components, like this model 1 for the clinical analysis, this is model 2 for the clinical plus MGMT, model 3 for the clinical plus radiomics, model 4 basically clinical plus MGMT plus radiomics. At the end, we did the analysis with the clinical MGMT, radiomics, and genomics. So that shows a clear separation with the short survival, middle survivors, and the long survivors. That shows the synergistic effect of all the component like genomics, radiomics, clinical, and MGMT for the survival analysis of the glioblastoma patients. So this was the case study 3. Another case study 4, that is an integrated radiomics graph attention network for the prognostic prediction in IDH wild type glioblastoma multiform patient. Shortly, it is called as a RAGA-net. So we have used the radiomics, we have used the graph-based architecture, we have used the attention mechanism for creating the entire pipeline or building the model for the survival estimation of the IDH wild type glioblastoma patient. So this is the overall flow. Again, we have considered T1, T2 flare and T1 GD. Instead of using only the traditional or deep features, we have computed the graph based features. We wanted to identify how these different sub-regions, like different sub-region of the whole tumor are interrelated with each other. So that's why we have computed the graph based features. Then we have implemented the feature selection features. Then we, at the end, we have implemented the attention based mechanism to find out the important weights for the various features. Then we did the survival for the short survival analysis and for the long survival analysis. So radiomic features, I'm not going to the detail of the radiomic features. We have used the structural based MRI, and these are the traditional texture based, intensity based. These are the deep features. These are the graph features. I would want to emphasize on the graph features, like here only. Then I would want to emphasize on the graph-based features. I am just skipping the deep like texture features because already we have discussed in the couple of slides earlier. These are the GLCM, GLRLM, GLSZM features that we have used. Deep radiomics, we have used the convolutional neural network. This is the important concept that you can understand why graph are important. We wanted to identify how different regions are of the whole tumor are interrelated with each other. So for that, what it did, we have created adjacency matrix to find out the correlations between the different components with the different slides. Let me give you the brief overview about the modalities that we use. Like a patient who are suffering from glioblastoma, he or she went for the T1GD scan or T1 scan. So the scan has a set of images, set of slices, Excel slices. So based on those slices, we wanted to analyze the relationship. So as you can see this in the figure here, like S1 is nothing but a slice one of one patient. Okay, ED is representation of the edema region, ET is representation of the enhancing tumor region, NC is the representation of the necrosis region. So by this way, we have created the feature matrix. Like for ED region, these are the F1, F2, F3, F4. We have extracted the 168 radiomic features for the ED region for the slice one. Again, we did we have extracted the region for the features for the enhancing tumor regions for the slice 1 and so on. So S155 is the representation of the 155th slice of one patient. So similarly, I mean, like this way, we have computed the feature matrix. For the connection purposes, what we did, we have computed the distances from S1ED to S2ET. S2ET is S1ED means edema region for the slice 1. S2ET, it means uh, enhancing tumor region for the slice 2. So we have computed the distance based on certain threshold. We have identified whether these ED region for slice 1 is connected with the ET region of slice 2 or not. So based on that, we have created the adjacency matrix here. Okay, so we wanted to identify the relationship between the different regions in different slices of the patient. So we have used these kind of features for this analysis as well. So these were the graph based features. At the end, we have used the attention mechanism for the post feature selection for prioritize the key features, adaptation to multimodal data. Basically, attention, it reduces the residual noise, it boosts predictive accuracy, and improves interpretability. So that's why we have used the attention mechanism for the post feature selection based methods. ROC curve, that I mean, this is the results that we are getting. Somehow the results was promising. Like we are getting the AUC around 0.94 with the I mean standard deviation of 0.04, and this in this figure 8 you can see that while using the only other radiomics we are getting the accuracy is around 0.84 AUC 0.84, and when we are using the weighted attention based mechanism we are getting the AUC is around 0.94. So these are the results are very promising. So somehow the graph based features boost the performance of the analysis. These are the results of the replication cohort. Like there's a p-value that we are getting less than 0.001, indicating there is a clear separance between the survival probability of the short survivors and long survivors. These are the AUC for the replication cohort. Somehow it is also showing the promising results. So I would want to also I would want to discuss my ongoing studies that is based on the beyond the tumor exploring. We are basically exploring the peritumoral lesions in the glioblastoma multiforme patients. So people are working on focusing on the tumor regions, but now we are working on we are working on the region outside the tumor. Okay, so to identify certain kind of a good signature that we can relate with the tumorous region with the non-tumorous region. So we have developed the pipeline with the vision transformer and the convolution neural network with the various feature selection scheme, and for again the identification of survival and NMT. Our main aim was not to identify whether our model is uh, predicting good in survival or an MGMT. Main aim was to analyze how these peritumoral lesions gives important information for any kind of a clinical analysis. So let me give it give it examples. So peritumoral regions are like this is the tumor regions we have dilated in various sense in the various direction of in the image, so that we can have more information, and we are just analyzing these regions in terms of MGMT methylation and in terms of the survival analysis, so that we can I mean there is a concept called as supratotal resection. So when patient is suffering from tumor, so at the time of surgery the doctor reject the some more regions outside the peritumoral regions outside the tumor, so that will help doctors to identify the infiltrative tumors so that they can resect accordingly. So these are the results that we are getting for the peritumoral based analysis. This is for the survival, and this is for the 8 mm survival. I mean 8 mm margin. Uh, like for this is the results, as you can see that whatever we are getting AUC is 0.74 for the survival prediction that we are getting for the 0 mm margin. It means this is prediction only based on the tumorous region, but this is the prediction that we are getting from after 8 mm margin. So it means that the 8 mm is 8 mm margin is having significant contribution in the survival estimation of the patient. This is another study, like based on the like based on the fused analysis, like we have used input data again the brain cancer, then LXNet and VGGNet we have combined. Again, this is transfer learning. LXNet and VGGNet we have combined here, and followed by different feature selection scheme like RFV, and then we did survival overall survival estimation and then GMT status estimation. This is a general flow that we have implemented in our analysis. The important point here is how we can how this transfer learning works in case of LXNet and VGGNet. Again, the results are good, like we are getting the promising result. So somehow our aim was not to find out the good accuracy. We want to find out certain good interesting information that we are getting from the any developed pipelines here. So this is about the results that we are getting. These are the scores. Like for accuracy, we are getting nearly 0.7.5, and here we are getting accuracy is 0.6. This is for the survival, and this is for the MGMT methylation. Now I'm coming towards a general scenario, like global disparities in the brain tumor care, specifically for the radiogenomics studies. Like these are the the overall scenario of the entire globe is divided into three categories, like high access points, high access countries, low access or no access countries, and the intermediate access countries. Like high access countries like United States, United Kingdom, they are having the high accessibility of the MRI imaging. They can access the molecular profiling like MGMT, IDH, and so on. They are having, the high access countries are having the availability of the neurosurgery, radiotherapy services, and so on. But in case of a low access like Nigeria, Namibia, so they are having the minimal access with the limited treatment facilities. But if you go towards the intermediate access, they are having a limited, like in some cases, in some region of a limited, intermediate access countries are having uh, appropriate centers to analyze brain cancer, but in some cases not. So there is a global disparity in the globe for the brain tumor care, specifically for the radiogenomics based studies. So AI can play a very important role by bridging these different groups like high access, intermediate access, and low access. So this is, as you can say, I'm not going into the detail of this table. So these are some of the example of the high access countries, some of the examples of intermediate access countries, and some of the example of low access countries. Like high access is having high MRI and diagnostic access, neurosurgery and radiotherapies. Their molecular profiling they can do easily. They are having a well-established neuro-oncology experts, and the health system strength for the USA is 18% of the GDP, which is WHO rank is 37. But in case of the low access countries like Haiti, Nepal, so they are having a very almost no access, uh, only urban based, and limited resources are there. So this discrimination based on high access, intermediate access, and low access can be bridged by the artificial intelligence. Okay, so this is basically the AI readiness index access disparity, the neuro-oncology, like USA, Germany, UK, Canada, Japan. So if we talk about the AI implementation, so we have computed the AI readiness index. So they are having index is very high comparative to the intermediate access countries, and in terms comparative to the low access countries. So they are also having high AI readiness index. They can implement the AI thing very easily because they are having a huge amount of genomic information, huge amount of radiomic information. So these are the 10 foundational principles that different groups of the intermediate access countries or low access countries can do with the help of the high access countries, like groups from the intermediate access countries or low access countries can work together with the high access countries by using these 10 foundational principles, so that to create a robust and generalized model, like standardized, they can do standardized processing, multi-model integration, ground truth transparency, global data set representation. They can do the open benchmarking. They can have global open science collaboration. Nowadays, instead of using the black box things, we can have the explainable AI integration. We can have the ethical and the equitable AI deployment. Most importantly, we should do, the groups from the low access and the intermediate access countries, they must have to do the external validation to build a generalized and the robust model, and the clinical utility focus based on the certain clinical utility. So these are the 10 foundational principles that the groups from or centers from the low access and intermediate access countries can do with the help of the high access countries. So we are going to introduce like the pragmatic BTC. Basically, this is a protocol for reproducible AI guidelines and multi-model analysis in tumor imaging and care for brain tumor care. As you can see that the inequity in the brain tumor care and inequity in the inequity in the brain tumor care from in the high income countries or high access countries, and the low and middle income countries or low and middle access countries, that can be bridged by the artificial intelligence. How it can be worked by filling the gaps in the standardized reproducible AI based method for the brain tumor analysis. So ultimately the thing is, AI is having the power to serve like a bridge between the low access resources and the high access resources based countries. So I would want to conclude here, like AI in radiogenomics, obviously it is important. It enhances the diagnostic accuracy, individualized therapy optimization, and it can be used for the progression and the recurrence monitoring of the cancer. And yes, this is a new hope to reduce the invasiveness, and it is basically based on the advancement in the research and clinical trials. So this is all about the things this is the general introduction of the radiogenomics. I have discussed the basic information about the radiogenomics, and I have discussed the couple of case studies of my group and the general scenario of the entire radiogenomics based studies in the entire globe. So thank you. Now I would want to conclude here. So is there any question? If there is any question, then feel free to ask.
Thank you, Dr. Saxena, for the wonderful and very informative sessions. The stage is now open for questions. If any of the participants want to ask questions to Dr. Saxena, can go ahead. Or they can paste or write their question in the chat box.
I can see the chat box, but I don't think any question. Thank
Yeah,
you.
there are praises for the talk, but no questions are there. Ashok Behra. Yes, sir. You can ask questions, sir.
Ma'am, I have granted permission to participant. They can unmute themselves.
हेलो
Yes, sir.
हेलो
Ashok Behra, sir.
हाँ जी, एक्चुअली वो खुल नहीं रहा था ना मैडम, इसीलिए मैं बात नहीं कर सक रहा था, परमिशन नहीं था हमें
हाँ,
ओपन
sir.
करने के लिए।
जी
या
You
प्लीज
can ask.
सर। हाँ सर, हाँ सर, नाइस सेशन सर। सर मेरा ये क्वेरी था कि सर जब हम कोई इमेज लेते हैं रिसर्च का बेसिकली, तो डॉक्टर ने इमेज लिया और अपना ज्ञान लगाया, और डॉक्टर अगर उसको आपने बताया बोला कि डिसीजन नहीं ले सक रहा है कि उसको ट्यूमर है या नहीं, या अगर है तो कितना लेवल तक है या क्या है, उससे तो वो तो अपना नॉलेज से प्रेडिक्ट करके बता देगा। मगर मैं एक चीज नहीं समझ सका कि आपने जो मेथिलेशन डीमेथिलेशन का बात किया उस एंजाइम का बारे में, the what is that some enzyme name MMT or some enzyme that is having MGM. It is having some role. If there is a methylation in this enzyme, then there is a chance of glioblastoma will be less. That's a good thing. That normal person is having this methylation part is more. If I am not wrong, normal human beings are having. So my yes, it indicates that it is suppressing. That means if it is having role, that means normal person is having the good amount of MGM methylation. So my question is that how you, because to do that methylation demethylation, one used to do in the wet lab the experiments like RT-PCR, PCR or Western blot experiments. But I don't understand how you predict that part in the AI tools. Can you show that slide and make us understand if I
that
can
is sure,
understand?
sure.
Please, yeah.
So, before sharing the slide, I just want to clarify one thing. In current clinical practice क्या होता है कि MGMT methylation identification के लिए the doctors go for the biopsy. Okay,
Yeah.
biopsy क्या
Yeah.
है? That is an invasive process.
Yeah.
हमारे पास आई मीन इंडिया में निम्हांस में भी आई डोंट थिंक दे डू बेसिकली एमजीएमटी बिकॉज इट इज ए एक्सपेंसिव प्रोसेस. ठीक है, पेशेंट जाना नहीं चाहता है, एक्सपेंसिव, लोगों सेंटर्स के पास अवेलेबिलिटी कम होती है फॉर द सीक्वेंसिंग. ठीक है, तो अभी के लिए फॉर आई मीन देयर आर कपल ऑफ सेंटर्स इन इंडिया, मेजॉरिटी इन यूनाइटेड स्टेट्स एंड यूके. द ओनली रिलायबल वे फॉर एमजीएमटी एनालिसिस इज द बायोप्सी. ठीक है, अब बायोप्सी में प्रॉब्लम एज आई डिस्कस्ड कि उसको करने के लिए थोड़े से पैसे मतलब ज़्यादा लगते हैं, एक्सपेंसिव प्रोसेस है और सेंटर्स के पास फैसिलिटीज़ भी नहीं है. हमारा काम ये था, मतलब उस रिसर्च में ये काम था कि हाउ वी कैन आइडेंटिफाई वेदर अ पेशेंट इज हैविंग एमजीएमटी मेथिलेशन यस और नो बाय यूजिंग एआई बेस्ड मेथड. तो इसके लिए वी हैव द सफिशिएंट अमाउंट ऑफ अ डेटा, एमआरआई डेटा with MGMT methylation information as a label हमारे पास, because अगर label नहीं होगा then we cannot train. I mean we can train but for getting the good result we must have the label. ठीक है, so हमारे पास डेटा था MGMT methylation का around 1000 patient or more than that. Based on that we trained the model. हम लोगों ने मॉडल ट्रेन किया और उससे प्रेडिक्ट करके ये बताया कि अगर डॉक्टर के पास कोई एक पेशेंट आता है, उसके पास सिर्फ एमआरआई इमेज होता है, वो मेरे सिस्टम में पास करेगा. मेरा सिस्टम या मेरा मॉडल दैट कैन आइडेंटिफाई वेदर दैट पेशेंट इज हैविंग एमजीएमटी मेथिलेशन यस और नो विदाउट यूजिंग एनी invasive process. So that is the overall scenario. Now I am telling you how we have done this.
Yeah. From that image. Yeah.
Let me share that screen. Yeah, this one in couple of studies that we did. 1 minute. You can see this. My screen is visible.
Yes sir, it's visible.
ठीक है. So this is basically what you did. We have taken these MRI modalities T1, T2, FLAIR and T180. Okay, we have taken these 4 modalities. We have extracted different regions. I mean this is the you can see this is the tumor region ना, यहाँ पे tumor है, यहाँ पे tumor है, यहाँ पे tumor है. So we have created small patches. ठीक है, patches in the sense की small rectangular box or filter kind of patches we have extracted. We have created the discovery cohort. Discovery cohort means the cohort that we are going to discover something. ठीक है, so हम लोगों ने ये we have created a bucket of the pool of patches by we have extracted the patches from here. Then we train the model. यहाँ पे हम लोगों ने मॉडल ट्रेन किया. ये मॉडल बेसिकली ensemble deep learning based मॉडल था. यहाँ मॉडल ट्रेन किया. Based on this model we did the prediction. Whether I mean we did the predict. This model was trained for the prediction like whether the patient will suffer from MGMT methylation yes or no. हम लोगों ने इसको टेस्ट किया. यहाँ पे रेप्लिकेशन कोहॉर्ट मींस द इंडिपेंडेंट कोहॉर्ट, इंडिपेंडेंट डेटा. इंडिपेंडेंट डेटा यहाँ पे मॉडल ट्रेन किया, ये इंडिपेंडेंट डेटा लिया, इंडिपेंडेंट डेटा को अपने मॉडल में पास किया एंड देन वी जस्ट आइडेंटिफाइड व्हाट इज द एक्यूरेसी दैट वी आर गेटिंग हियर. It sounds like good or not? I mean, is it clear?
नहीं, बट यहाँ से जैसे कि मैं एक चीज जानना चाहता था, दिस इज द पेशेंट्स MRI
हाँ
report, and
हाँ
if you compare with a normal person's MRI report,
हाँ
then
हाँ
only we can compare whether it is a methylation part is there or not, because it's a patient, no, so patient is having how much amount of methylation, and and a normal person is having how much amount of methylation, then we can compare and we can analyze that part in this. But here, where is that normal person then?
like for example, like you
Yeah,
can see this, you can see this figure. Okay, so
yeah,
I would not say norm, because in my data set normal person का MRI नहीं था, ठीक है, हम लोगों की जो डेटा सेट था उसमें all the patients are what suffering from glioblastoma. हम लोग ये आइडेंटिफाई करने वाले थे कि जो पेशेंट्स आर सफरिंग फ्रॉम ग्लायोब्लास्टोमा उनमें से किसमें मैथिलेशन है, किसमें नहीं है, और किसमें अप टू व्हाट एक्सटेंट द मैथिलेशन है, ठीक है, दैट इज वन थिंग. क्योंकि बेस्ड ऑन दैट कीमोथेरेपी या रेडियोथेरेपी डॉक्टर्स न्यूरोसर्जन प्लान्स, ठीक है. हमारे जो पेशेंट, जो हमारा जो मॉडल ट्रेन हुआ वो बेसिकली ऑल आर ग्लोब्लास्टोमा ट्यूमर बेस्ड पेशेंट, नॉट लाइक नॉर्मल पेशेंट नहीं थे. अब आपकी बात जो है कि हाउ वी कैन आई मीन कैसे हम लोग कंपेयर करेंगे, जैसे फॉर एग्जांपल ये वाला जो फिगर है, जैसे एमजीएमटी अनमेथिलेटेड पेशेंट का, एज यू कैन सी दैट ये जो ग्राफ
yeah.
शो कर रहा है ना, जैसे ब्लू रीजन, इट मींस कि ऑलमोस्ट एंटायर रीजन इज ब्लू, मींस दिस इज अनमेथिलेटेड. यहाँ पे थोड़ा सा हल्का सा मिला रेडिशनेस है हल्का सा, यहाँ पे कुछ साइड में मेथिलेशन दिख रहा है, बट मेजरली इट इज अनमेथिलेटेड. हियरली यहाँ पे थोड़ा सा मिड लाइन के अक्रॉस थोड़ा सा मेथिलेशन मिल रहा है, बट मेजरली इट इज अनमेथिलेटेड. यहाँ पे क्या हो रहा है, एंटायर इज
तो
अनमेथिलेटेड.
नहीं है सर,
बट
बंद कर दीजिए ना ये।
हेलो
हाँ हाँ, बंद कर दीजिए मेरा।
hello, or and for these four patient, as you can see that the entire matlab entire region is methylated. So but these four patients all are suffering from glioblastoma. Okay, सबके अंदर मतलब सब all are suffering from glioblastoma. This
Yes,
is not
okay,
the normal patient MRIs. हम लोगों का काम
okay,
मतलब our work was to tell doctor like this patient is having GBM. My system can tell you whether this patient is is having MGMT methylation, yes or no. If yes, then in which region MGMT methylation percentage is high and in which region MGMT percentage is low.
जैसे कि सर एक चीज मैं बताना सर ऐड करना चाहूंगा कि अगर वो पेशेंट को अगर ट्रीटमेंट किया जा रहा है, मीन ग्लाइबस्टोमा का वो ट्रीटमेंट ले रहा है, ड्रग थेरेपी ले रहा है, तो हम डिफरेंट टाइम पीरियड में अगर इमेज लिया जाए और उसके बाद एनालाइज किया जाए और
Yes.
उसका मेथिलेशन और डीमेथिलेशन दे, देन इट कुड बी फ्रूटफुल, आई बिलीव सो. अगर हम पेशेंट का लिया और देखा और यहाँ पे तो जितने सारे दिख रहा है मेथिलेशन तो है ही है, तो मैं तो समझ नहीं सक रहा हूँ कैसे एक्चुअली ट्रीटमेंट. जैसे कि मैं एक चीज जानता हूँ कि जब कैंसर होता है या कोई भी चीज होता है, कोई भी ट्यूमर में कोई भी जीन और प्रोटीन ओवर एक्सप्रेस हो जाते हैं या डाउन रेगुलेटेड हो जाते हैं, दोनों चीज में से कुछ एक चीज होता है, तो हम उसको मार्कर के हिसाब में देखते हैं सर. तो यहाँ पे अगर आप बोल रहे हो मैथिल जीन में अगर मेथिलेशन हो जा रहा है तो ट्रीटमेंट हो जा रहा है, तो कुछ ना तो कुछ हो रहा है ना सर. तो वो अगर मार्कर है तो हम अगर पेशेंट्स में उसका वैल्यू घट जाएगा और नॉर्मल पर्सन में वो बढ़ जाएगा. मेरा गेस है सर, मैं जो सोचा मैं आपको मेरा पॉइंट रखा
नहीं नहीं
सर,
नहीं,
बस
नाइस क्वेश्चन.
ये सर मेरा ये थिंकिंग था कि ऐसे भी करके हम देख सकते हैं, क्योंकि आपने जो काम किया है दैट इज गुड, क्योंकि इमेज लेके प्रोसेस करके ये देखा जा रहा है, तो ये तो बहुत अमाउंट का केमिकल सेव कर रहा है ना सर. डेफिनेटली वेट लैब का काम बहुत सेव कर रहा है, इट्स गुड वर्क. मगर मेरा ये सजेशन है, अगर आप ऐसे अगर डॉक्टर आपको दे रहा है तो ट्रीटमेंट वाले जो पेशेंट्स होते हैं उनका अगर हम रिपोर्ट अगर एनालाइज करें और कंपेयर करें तो बहुत बढ़िया काम होगा सर.
नहीं
आई
दैट
बिलीव
इज
सो सर.
नहीं, दैट इज कॉल्ड एज लॉन्गिट्यूडिनल एनालिसिस. जिसमें होता क्या है ना कि जैसे आपने बोला कि जैसे कोई ट्रीटमेंट दिएगा ए पेशेंट, जैसे फॉर एग्जांपल दीज आर 4 पेशेंट एमजीएमटी मेथिलेटेड पेशेंट्स है, ठीक है.
हाँ सर, हाँ
अब
सर,
दीज आर एमजीएमटी मेथिलेशन का मतलब ये नहीं कि एमजीएमटी मेथिलेशन होगा और ग्लोब्लास्टोमा है तो पेशेंट को डॉक्टर छोड़ देगा कि नहीं यार तुम जाओ, तुम्हारा एमजीएमटी मेथिलेशन है, यू विल बी फाइन, यू आर फाइन. बट ऐसा नहीं होगा. डॉक्टर विल स्टार्ट देयर ट्रीटमेंट विद टीएमजी, टेमोजोलोमाइड से कीमो रेडियो करेगा, ठीक है. After some time, I mean after just follow up scan hoga, after 2-3 months follow up scan mein again the doctor will identify what is the percentage of MGMT methylation after chemo and radio. Is it clear? So
हाँ
again
सर
again at that time our system will tell doctor कि अच्छा वो doctor क्या करेगा, doctor again will pass his or her MRI in our system after 2-3 months in the follow up scan. That patient, I mean doctor will pass again that MRI to our system, and our system will identify whether मेथिलेशन परसेंटेज क्या है, कम हो गया है, कोई ऐसा तो नहीं कोई साइड इफेक्ट विद इन्फिल्ट्रेशन के कारण या सूडो प्रोग्रेशन या प्रोग्रेशन के कारण कहीं कुछ और इफेक्ट तो नहीं हो रहा है, तो वो फिर अगेन आवर सिस्टम विल आइडेंटिफाई कि एमजीएमटी मेथिलेशन है नहीं है, अगर है तो अप टू व्हाट एक्सटेंट है. इज इट क्लियर?
यस सर. हाँ
तो
सर समझ रहा हूँ मैं सर.
हाँ तो I mean that is called longitudinal analysis, like time wise वो करना है. तो ultimately we are guiding the doctors. I mean we are giving some important information to the doctor whether MGMT methylation is yes or not. If yes, then what is the percentage? ठीक है
ये सर अगर हम एक स्टेटमेंट दे रहे हैं सर, हम एक स्टेटमेंट दे रहे हैं कि नहीं अगर ये मेथिलेशन होता है तो इसका सर्वाइवल चांस बढ़ जाता है, तो उसको प्रूव करने के लिए आई थिंक एक बार हम नॉर्मल का भी देखना चाहिए. इट्स माय पॉइंट सर. दैट्स इट सर.
ठीक है.
थैंक यू सर.
थैंक यू.
Thank you, sir. I hope your queries were answered by Dr. Saxena. And we have one more question, sir, in the chat box. Deblu Sahu is asking, the training was done with the patches or MRI slices?
Patches of MRI, I mean, let me patches of the MRI slices covering the tumor. I mean, we have extracted the patches from the tumor region only.
Okay, any other question from the participants? I think, sir, there is no more question, so we can proceed ahead. Sir, thank you very much for such an enlightening session and very informative session. And we would like to present you with a virtual memento from our organizing team. Kindly accept the memento, sir, from our
Thank
behalf.
you. I will definitely accept in this memento.
Yes, sir. Kindly accept this. Thank you, sir. Thanks a
Thank
lot
you. Thank you, ma'am. Thank you
for joining the session.
Thank you, ma'am. Thanks a lot. Thanks, Gaurav,
Thank you,
sir, and Yuvnesh, sir.
अरे सर
Hi, sir. ठीक है.
सर
Thank you, sir. Thank you
thanks
so much,
for
sir.
Thank ठीक है, sir. But you
Sir.
just continue your FDP.
sir, thanks for your time, sir.
Okay, thank you,
Thank you,
sir.
sir. Thank you for your time, sir.
Bye bye,
Bye.
sir.
So I hope our next speaker has joined the session. Mr.
Yes, yes,
Yogendra Swarup Dwivedi. Sir,
yes,
are you
ma'am.
there?
Yes, I'm audible.
Yes, sir, you are audible, sir.
Yeah. So, do we need like a break because it was a long session, or shall I start?
We can start, sir.
Okay, sure.
Yes, sir. So you can turn on your camera, sir.
Sure.
If possible. Yeah.
Yeah.
So next, I am very pleased to welcome Mr. Yogendra Swarup Dwivedi from Ericsson Gurgaon, who brings an industry perspective to our discussion today. Yogendra Dwivedi sir received the Master's in Science degree in Physics from IIT Roorkee, India in 2004 and the MTech degree in Applied Optics from IIT Delhi, India in 2007. Having more than 17 years industrial and research experience across countries, Yogendra sir is currently working as a senior software architect at Ericsson Gurgaon, India. He is pursuing doctoral research at NIT Delhi. He has published several research articles in reputed international journals. His areas of research include fiber optic sensors, photonic devices, artificial intelligence, and their applications. Mr. Dwivedi is an active member of IEEE as well. His talk today is entitled Quantum Enhanced Sensing and Decision Systems from Teleportation to Real World Application. This will be an exciting and futuristic topic that will bridge quantum computing and real world engineering challenges. And I hope this will be a session that we will going to remember. Sir, the virtual stage is yours. Thank you, sir,
Thanks,
for joining.
ma'am. Thanks for nice introduction. Ma'am, I have a request because
Yes, sir.
let me share my screen. because this field is like very new and like if you ask like a great physicist like Richard Feynman, he told like everyone like talk about this quantum, but no one knows or no one understand it. So it's a bit tricky, and please interrupt me in the middle if any question in the like from the audience, and
Definitely, sir.
yeah.
I encourage all the participants to ask questions in between if they feel like.
Yes, 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 please. Because what I want, like, it's not a presentation; it's a discussion. Because even I consider myself as a like new student in this field, and although like during my like MSc 3 semester, I went to this quantum computing, not computing, quantum mechanics, and then like in MTech also. So yeah, but still I can say like I'm learning quantum thing. So for like next 40 or 50 minutes, so it should be a discussion, and like all are like I'm requesting all the participants to ask any question related to quantum whatsoever in their mind. They are free to discuss with me. So yeah, so
Yes.
without any delay, let me. My screen is
Your
visible.
PPT is, yes, yes, it is visible,
Let
sir.
me full
Please make it
screen.
in full screen.
Yeah.
Yeah, it's fine.
So today, what we are going to do is like a discussion how quantum computing is helping us in decision making. uh, Last week I like my one of the paper got published in IEEE, and it was like how to like reduce noise using quantum computing, and why quantum computing is beneficial than the traditional AI things like AI nowadays. Generative AI is there, attention, all those things. So I have many papers in all these technologies earlier. From last year, I moved to this quantum computing. So I will show you like why quantum computing, why we should read this quantum thing. So before this, let me just show you my mm, desktop, and I want to show you the countries investing in quantum computing. All the like developed and few developing countries are investing a lot in quantum computing. There is a reason. Still quantum computing have few challenges like noise, decoherence, and they are trying to solve these problems. Once it's solved by any country, they will hack the system of all other countries within a minute. That's why they are spending a lot, like just reduce this noise, just reduce this decoherence, and make it like a very good quantum computer which is without these errors. If this is reality, then they will like hack the other system within a minute. If quantum computer is very working very well, you can like know any password, any banking password, any site password. So that's the power of quantum computing. If you see like here like Australia, it's like first Australia is spending like very less, 1994 US $1 million. If I move to the last, like the first is US, and it's like 1.275 billion dollar in 2018. 2024-25 budget is much more. So there is a reason, as I mentioned. If quantum computing is without noise, it can do anything whatsoever you think, from hacking other countries' system to treating a cancer. We have a concept of quantum medicines also. Like when quantum medicines are there in the market, they can treat very efficiently any disease. So that's why like I showed you, and if time permits, because time is very less. So last week this paper got published, and it's like how we can reduce noise from a sensors using this quantum computing, and its results are like promising, and the results are trying a natural way. Like AI/ML is there, okay? Definitely we can use AI/ML and classical methods, classical machine learning things. But there is a problem. When they works, they are not enough intelligent to work like a human or what we want. But quantum computing or quantum world is very, very intelligent. Even a single photon ray of light is super intelligent what to do. So if we can harness that thing, that quantum thing, in our real world, that's very amazing. So this, if time permits, I will discuss this paper. Now I'm coming back to my presentation. So before this presentation, like I was trying to show you why you should listen to me, or why you should think about, like why should I read the quantum computing about quantum thing. Yeah. Moving to the next slide. So because this program is mainly for like health oriented, so I created this like a PPT towards more like health. Like what we want, like nowadays we have like many devices, and if you see like if you go to hospital, most of the devices are like from the physics, or like operating with a precision. What we want, like these devices should work with high precision. Even like if I talk about digital thermometer, or blood pressure monitor at what we are using at home, if you just check like your BP once, it's giving like 125 and 82, just immediately press the start button again. It may give 190 and 90. So there is a precision in like with that particular device and any device. And the motivation is like how we can increase its precision and sensing accuracy. Definitely we are using the conventional method, but when like we use this quantum computing or quantum mechanism with these devices, definitely we can increase its precision and the sensing accuracy. Please feel free to interrupt me in the middle. I am always very happy. Yeah. So if I talk about like the quantum in smart health, what we are using like simulation nowadays when we are designing like a healthcare device, any sensor in healthcare, even like very small devices, like from the sugar monitor chip which we use to our home, and the higher end MRI machine. Definitely we are using simulation, and nowadays it's like AI and ML, machine learning we are using to increase its like optimizing all the things and increase its like sensing thing and optimizing its precision. And still there is a limit. We can't go beyond a particular limit, and we can see like if you are using a particular machine, as I gave example of blood pressure monitor, there is a limit. Like you can apply the machine learning and AI thing, like it's a sensing in a fraction of seconds, and no posture is required. Even you are like a standing position, it can like sense your blood pressure. But still there is a gap, and uh, in terms of accuracy and precision. If we use quantum in healthcare, that particular gap and latency we can like reduce a lot. So I'm taking very like one of the very common example where quantum phenomena takes in picture, and it's a governing the all the things, and that is like photosynthesis. There's like I read it in a class ninth when I was like photosynthesis, like sunlight is there, or in physics we say like photon is there, and we have a leaf, and chlorophyll is there, and when like that particular light is there in that particular plant, or in that leaf, it generates energy, it creates its food, and like take carbon dioxide, emit oxygen. It was very simple at that time, like yeah, it's very simple. It like light is required, and then chlorophyll plant, this particular plant is developing or creating its food, developing energy. But believe me, I read many books on this, like quantum supremacy, and they are saying this is the most efficient process in the nature, this photosynthesis. It's almost 100% efficient. If two photons are coming, the plants are creating energy using those photons 100%. No other process is so efficient. I am talking about natural process as compared to this photosynthesis. If I talk about the process or the instruments created by human, like our air conditioner we are using, it's very inefficient. To drain our heat, it requires external energy, that's like power, and it requires a lot of power. That's why when we are running AC, and if it's a window AC, just if you stood outside the window AC, you will feel more and more heat, because it's exhausting our room heat, plus the energy it's withdrawing from our electrical cable, it's converting that into heat also. So if it is reducing 10 amount of heat, it's exhausting around 15 plus 5 from the electrical circuit. So it's not very efficient or not even efficient, but photosynthesis is very efficient. And what's behind that photosynthesis is the quantum phenomena, or the quantum coherence takes place, and scientists start studying a lot how these leaves are using this quantum nature of light to produce such an efficient process. And if we can learn from it, definitely we can create the machines and the quantum medicines, which will help a lot in treatment of disease, and very efficient machines. You can just see is like a product is here, and suppose one light or one photon is landed in the leaf. That photon is very intelligent, because it's a quantum particle, and suppose it's landing in a particular portion in the leaf, it traverses a lot of path in that particular leaf, and finds where it will get absorbed, and it will create like a photosynthesis. So the whole traversal, scientists are still like unaware how it's deciding like where to traverse. That's why it's like I'm saying, like when it's a very efficient natural process, but very difficult to understand it completely. And the another is like enzymatic tunneling, like enzymes are tunneling. That's another quantum process, is still like under investigation how this quantum phenomena is taking care. And the third is magnetoreception in the birds. Birds are like traversing. We heard like many birds are coming from the Europe in India in the winter time, and the question is how do they remember this, like the location or the path which, and they when they are coming from Europe to India, or going back from India to Europe, they are using the optimal path. That path they have minimum length, and their food thing, water, and all those things. It's like they are using the magnetic field of the earth, again a quantum process. So I just presented these example to give you a like glimpse. In nature we have many processes which are very efficient, and those are governed by this quantum mechanism or quantum phenomena. And a few of the examples I gave in like the biology. So this was like I was just explaining, photosynthesis is a quantum coherent process. So if you can just see here, like photon just arrived at this particular like pigment. I don't know more about biology, and it's like going from here to another pigment, another, and it know like where is the reaction center, where it need to go. And if you just see this path, it's like wave like of a structure. So photon is like considered as a particle, and as a wave also it have a dual nature, and this dual nature creates this quantum mechanics very great. Like it's converted into wave like structure, and wave is, we have wavelength, and it's spread over all this region. And this wave nature determines where it will get absorbed, and then finally it's absorbing at this particular point. So yeah, as I explained or wrote here, like excitation energy explores multiple paths simultaneously. This superposition is if someone says about quantum computing, so it's based on mainly two things. One is superposition, and other is entanglement. I will explain in upcoming slides what is superposition and entanglement, but from here you can just say it's not in a single position, it's not on this particular green, but it's on many positions, this particular photon using wave nature. So not a single position, it's in almost all the position, or this is known as superposition. So superposition makes this quantum thing or quantum computing different from all the computing or all the other phenomena. So not a single place, it's over all the places. And then when it's all the places, it finds like where it's best required, and this particular photon is getting absorbed at that place only. So superposition is the thing, and the same happens when this light is like landed in a leaf, and it creating this photosynthesis process. And it's all the things are done in femtoseconds. It's not like it's like traversing and taking 1 second or 2 seconds. It's like femtoseconds, like very very fraction of seconds. All the things are happening. That's why it's very efficient. Ma'am, any question till now or any query? Uh, if not, then I think I can go ahead. And if any query, please stop me, and I will try to explain that particular thing. And if
Sir,
anyone,
sir, participant is muted, so should I permit them to unmute themselves?
or they, if they are writing in the chat window, please tell
Okay,
me
sir.
like,
Sir, I have granted the permission to unmute themselves. Okay, sir.
yeah.
Okay, sir.
So anyone, any query, and I believe no question is silly. So whatsoever in your mind, you can ask. I think no question for now. So uh, I'm moving further. So, like, how this quantum computing or quantum algorithm can help in our like biotechnology or our like medicine thing. So, VQ is variational quantum encoder, the short form of VQE, for drug discovery. I will explain like how it will help in like very simple in very simple terms. QAOA, it's optimization term for protein ligament optimization and quantum similarity search in genomics. So as I mentioned, like drug discovery is a very critical thing in healthcare, and we know the criticality at the time of COVID, when many like pharma companies were trying to discover the drug for that COVID, and they were trying different combination, and like one combination is done, then it's like trial another combination. So what we have in combination, we are combining many salts at a particular position, and then testing it, then another, then another. But in the, as I mentioned in the last slide, this quantum have a nature of superposition. Superposition means, I'm just thinking in terms of like a drug. When we are discovering a drug, we need to uh, mix different salt in different proposition. What if a computer like quantum computer can give you a result in one go of all the combination? Quantum computing can do this in like fraction of second, all the combination result. How? Because it's using superposition. It will not try one by one, it's in all the states, it's in all the position at a given moment of time. Then it can combine, or it can just estimate all the proposition of all the salts in one go and give results in like 1 second or like fraction of seconds. So actually I tried in the like real quantum hardware in IBM quantum hardware USA, and they are giving API, and 10 minutes it's free for like anyone. If you have Google account, and anyone can try, you will find like the results or the computing which you are doing in normally, and takes around half an hour or 1 minute. If you are trying that thing, and if you can just transfer the data into quantum state, hardly it's like 1 second. In 1 second it's like 1,000 times it's doing it. Like once one like result is giving one time, second time, third time, and 1,024 times it's gave result in a fraction of second. So it's very very fast due to this superposition. And the similarly QAOA is like optimization thing which we can use for like protein ligament optimization. And another thing is like quantum similarity. Like we are matching the DNA. So quantum is in like higher and higher dimension. So with very very less data in machine learning, what we have like I was in last presentation also. So suppose we have a data, and
Sir, sorry to
uh,
interrupt.
yeah,
I think we have one query from Ashok Behra.
yes please.
Sir.
Ashok Behra,
Yes,
sir.
sir. Yes, sir.
Yeah,
Sir,
please.
Yes, sir, go
you
ahead.
said that to BQE, that is variation quantum algorithm, or what is that variation
So
quantum?
yeah, estimate it's like VQA is the algorithm, variational quantum algorithm. VQA is based on.
Uh,
Surely I will share that, and I have a paper
so how
also.
to no, yes, sir. How to use this for this protein ligand optimization, or only for optimization it is used, or for other thing?
Sir,
Can you please
here
show us
actually
one
I.
example?
Hmm.
If you can show us one example, what you have done in your research work, so it will be useful.
Sure, sure.
Really,
I
sir.
will, I will go to my paper, which is published, and many papers are in queue where I have
Okay, how to
used
use
this.
this also?
Yeah,
Yeah, how
sure.
to use
I
this?
will
If you
tell
can
you.
show us, then it will.
Yeah,
Okay, sir.
I
Thank you,
will.
sir.
I will go through that
Okay.
paper. And sir, but like in the similar, like very simpler term, I want to say all the algorithms like mentioned here uses that superposition thing. Superposition means quantum computing or quantum is in all the states all the time, like at a particular like instant of time. Suppose you have 500 combination. Okay. So let me just give another example. uh, I have is this visible? One note.
Yes, sir.
Yeah. So let me just start with like we have a game, and in newspaper, sorry for this bad writing, that's called maze game. Maze game is one point is entry point, and another is exit. You need to enter from here. In newspaper also we saw too many times, and in the backside of comics. And then there are many like obstacle like this. I'm just drawing it randomly like this, and they create like this structure. So this is a maze game, and I think I closed it completely, but structure is like this. Yeah. So structure is like you need to enter from here.
अगला में भी छुट्टी डाले हुए हैं
Ma'am, please mute. Like so, you need to enter from here, and someone wins who can exit. So what we were doing when we were playing this game, we were just traversing this path, this path, this path. Oh, it's closed. Come back. Oh, like one round is done. Again, we are traversing another path. If this is closed, come back again, traverse to another path, again, and like this we were just traversing all the paths, and finally we were getting one path which leads to this. So suppose there are like uh, n cross m barriers in this, and it comes out around 50. So we need to traverse the 50 path. First go, come back, it's closed, and again try another, it's closed, and this. So 50 times we need to try, and then finally we are getting this path. So this is like a classical computer. If you solve this maze problem with classical computer, it will take 50 attempts, or like 50 if else loop. If else, like if this path is blocked, come, else this 50 times we need to traverse. What about this quantum computing? Quantum computing says, if I am a quantum computer, I am in superposition. I am not a particle. I am not confined as a particle. I am a wave. Like we have this particular wave. And what is the property of wave? Wave is spread. So it's like wave is completely spread over this. And if you ask, because it's spread, it's in the superposition in this maze. And if you ask what is the path, what is the path for out, it in one go, in one try, it will tell you this is the, let me use another color. In one go it will tell this is the path, because it's in the superposition, it's not in single position. It's spread. This wave nature of this quantum particle is spread over the maze, and in one go it can tell what is the best path. In the similar fashion, we have drug. Suppose drug discovery is there, we have like many salts. These are the salts, and proposition is also there, like what is the best to solve this. So it will not try one by one, like first try this, second try this combination, third, fourth. In one go it will try all the things and give the result. To simplify this, again I am giving you another example, and it's like so suppose you have a dice. We play ludo, and we have this dice, and it have like 6 outcomes, 1 2 3 4 5 6. In classical word, we can say like, okay, one outcome is probable. If we are like rolling this dice, only one will come, or 2 3 4 5 6. Six combination of six probabilities are there. This is classical word. In quantum word plays when I am rolling this dice. I am just using a small container. Dice is inside the container. I am just rotating it. I am not like thrown it this particular dice. It's in rotation state. So if you ask like 1, 2, 3, 4, 5, 6, which particular number? Anyone say any number. At that time, at that rotation, any numbers possibilities are there. Either one, either two, either three, or four, or five, six. In I am giving another simpler example. One coin is there. It have head and tail. Okay. Only two outcomes are possible, either head or tail. But what when that particular coin is in the air? You will say there is probability of both. When the coin is particular in the air, either head or tail. But when it's a air, both are there, head and tail. When it's collapsed in our arm or ground, then only one outcome will come, either head or tail. But when it's in the air, both are probable. In the similar way, quantum says, or like quantum word, all the possibilities at a particular same time, at a particular instant, it have all the possibilities, and max probable part possibility will collapse or come when we measure it in classical word. In the similar, we use it for drug discovery. All the combinations are there when we are using quantum computer, and when we collapse system measure, it will give you the best possible thing. Hope I tried to explain a bit of like how quantum word is totally different over classical word, in terms of like all the states are possible at a particular moment, and it's based on the probability. like which state is more probable that outcome will come. Yeah. So moving again to like in the similar way, like all the things like whether it's the quantum similarity, because states are in like all the states are there. If I'm doing for a DNA, all the DNA, I don't know more about DNA, states are there, and when I'm matching, it will perfectly match the DNA. So now like a bit more about what is this uh, quantum thing, or because I talked first, shown you the like how many countries and how much they are spending in this quantum computer. Then like one very efficient this quantum process, photosynthesis, then how we can use. And now I'm like a bit coming to like what is this quantum computing. So even if you are not getting a lot, that's no issue, because it's completely, but just see it like what is this. Like, now we know like a bit we have in normal computer bit, so it like works and 0 and 1 inside. At the last, what you are like, if you are opening a video or any like a picture, at the largest it's stored in the 0 and 1, so either 0 or 1. But in quantum, it's like qubit, qu for quantum, and a bit for like old bit, so it's a quantum bit. So it quantum anything we shows by the psi function. Psi of cat is alpha 0 and beta 1. So and alpha and beta are probabilities. So they are saying it's not 0 or 1 at a time, it's both. It's 0 as well as 1 all the time, with some probability alpha and beta. So it gives a lot of degree of freedom for our calculation. Any probability of alpha, and just think like only 0 and 1, and if like any drug combination, so suppose 5 salts are there, it will give first salt, second salt, third, fourth, fifth, alpha, beta, gamma, theta, and theta 2, and so on. All the combination are at particular time, all the combination are possible. So this is our wave function, or quantum bit. And if I say about like my work which I did is like FBG, fiber Bragg grating sensors. So it involves like incident spectrum, and it sense the outside medium, the refractive index, either it's a hemoglobin or like a concentration of or alteration in milk, and it's a very like sensitive. If some small changes are there in hemoglobin, it will tell like what are the changes, and one dip in transmitted, and this sharp peak will come in reflected spectrum. So that's used for as a sensor, FBG. There are biomedical applications of FBG, like in body temperature, pressure monitoring, and smart catheters, and variable, and for postures they use this FBG. So these are like biomedical applications, instead of like other than biomedical are railway track bending, and in tunnels we use like whether like a tunnel shape is changing, and bridges, if like train went over the bridge, whether shape is same or not. And because it works on light, and like wavelength is like uh, nanometer fraction of the change it can these sensors can detect, and that's why they are like heavily used where very high precision is required. And as I mentioned, like in quantum world or in any devices, the two problem, one is like noise can impact the results, and the other thing is like inference in the multiple, like we have many setups. Each setup, because it's like electromagnetic wave at the last, this light is, it can interfere with the other things. So these are the real time challenges with these devices. And how this quantum will like work or improve that particular thing. So what we did, you can just see here like this is the initial wave function or initial state of a particular system, and then we use denoising using quantum thing. So we removed the noise, and finally we got the better signal. Definitely we can use the classical ML and classical things, but those are not so efficient and not so intelligent as compared to this quantum thing. And quantum denoising is people, I have read many papers, research papers. It's not still in medical or like in healthcare, but when people will use, definitely it will come in devices, and then at that time the chances of errors are very very less. So these devices will become more intelligent for us, and definitely noises and errors rate will go down. As I mentioned, like a very simple example of blood pressure monitor at our home, or like we have sugar monitoring. If same time you use two times that even blood pressure monitor, it will give different reading. So some errors are there even for these small and the devices which are at almost all the homes. So in the big devices also we have some chances of errors, like what we are seeing from MRI. There are chances of noise and this, and if you can remove using this quantum, it can enhance a lot in that particular device. And as like someone asked, how we can use for this, the main or I can say the tricky part is because quantum world is different. Quantum world, as I mentioned, like is the dice when we are rotating, or the coin in the air. So quantum devices or quantum hardware is a totally different realm or world. The problem is because we are living in classical world, Newtonian world, where we have classical data. And suppose it's a drug, okay, this is the structure and how many milligram of that particular drug, or we have this temperature sensor, temperature is 27 degrees centigrade. How to convert or encode this data into quantum data? That's the one of the challenge, and we can't convert all the data into quantum data. And still there are problems when we are converting. It's not 100% in quantum realm. So the first thing is q0 qn is like quantum bit, and we have our classical data, how to convert this particular data into the quantum world. So there are few techniques. One is like amplitude encoding, phase encoding. Using those, we are converting our data into quantum world, and then changing that data as per our requirement using some tricks. And these the tricks are known as gates in the quantum world. Gates is nothing like, suppose I am using a photon, then gate is a rotator, or what we have, polarized thing. So electric field we are applying based on our situation, and then we are creating our whole problem, and then we are leaving the system and trying to get it like how naturally it will evolve and give output, and that particular output we are using for our work. So two main problem. One is how to convert our classical world data into quantum world, and the another other thing is we can't hold that quantum world data for a long. Even for nanosecond, it's not very easy, because it's changing its state, and that's known as decoherence. Decoherence is the main problem in quantum world. If this is solved, or it's resolved, then definitely quantum computing will replace all the classical computing, and we will work in quantum computers. So I was telling about the swap test for the similarity. We have one wave function, psi, and the phi is there. A swap gate is there. As I mentioned, like what we are doing any work or environment by this gate, and then we are doing this and measuring whether the both the DNA structures are same and not. And quantum works very very efficiently in matching or swap test whether structures are same and not, and within like fraction of second it can tell with max precision. And as I mentioned, denoising is there, we are using filters quantum machine learning thing we can use to, yeah, uh, get the denoising. And first thing, I will not take much time, it's 1 o'clock only, just 5 minutes, because it's lunch time for others also. First thing I mentioned, superposition. Quantum particle is not in one position, it's all the state, there's no superposition. Another thing which quantum computing uses is teleportation. Teleportation means, and China did this experiment in 2022, it's published. IIT Delhi, last week, in newspaper, also in news, there was a report like quantum communication over the length of 1 kilometer from IIT Delhi and some other organization collaboration, from like up to a distance of 1 kilometer, they can communicate using this quantum teleportation. These two particles, if entangled, I am not explaining what is entangled. Entangled is just like, if you take these two particles closer, and they are in a Bell state, they know each other, and then you took them apart. One is here in Earth, another quantum particle in Moon. In real time, they communicate with each other. If you change something here in Earth, the other quantum particle which was entangled with this first particle, in real time, it knows what was the change in this first quantum particle. And till the date, even Einstein worked like to solve this mystery, how it's working. No one knows how it's working, this teleportation, how this both particle are talking in real time. No medium, no wire, nothing is required, just they are talking with each other. They know like how other position, or if any changes are there, this particle in real time will come to know what are the changes. And people are trying to use this for communication. If one data I am speaking here, I'm somehow I am able to like transform my data in quantum state, and another particle is there, like I am in Delhi, another person is in Chennai. In real time, if they can decode, it's like communication medium, and people are using this particular teleportation, quantum teleportation, for communication. That's next revolution in communication and other things. Yeah. So this is the circuit, as I mentioned. I will not go deeper. This is quantum teleportation circuit, how we can realize this quantum teleportation. And mention also like fidelity preserving in multi-node sensor, and potential and secure. One thing is, no one can copy quantum state. So there is no chance like anyone can copy and paste. There is like security breach, not possible in quantum world. And now it's like telecom to healthcare anomaly detection. Some anomalies are there, like cancer tissues and some other issues. So if we can like harness this quantum computing, definitely very efficiently we can tell the anomaly in healthcare also. So in summary, like as I like started like from the benefits, or like what's going in quantum world, how countries are investing, and definitely quantum computing can enhance sensing and analytics. And then I moved to like my work, FBG sensor noise reduction. And definitely this quantum computing will work or will help in healthcare domain also. Yeah, so that's all. And yeah, please, any questions or queries, ask.
Yes, I open the session for questions from participants. Thank you, sir, for such an enlightening session about
Thank you, ma'am.
AI and computing, quantum computing, use of quantum computing in biomedical engineering.
Yeah, ma'am. What I want, like, people should explore, at least read about this, because this
Yes,
is
yes.
futuristic technology,
This
and
seems like a
definitely,
very new area, yeah, an
yeah, new
emerging
area,
area.
very new area.
Yes, yes. And especially to people working in biological area, biological sciences and
Mm.
bioengineering.
Yes,
So
it
it
will
just
change
seems a very
the
new
whole
and
thing
exciting
once.
area. Yes,
Yes.
yes. So If any participant has any question, they can ask now.
I will share the PPT if later someone have any doubt. So email ID
Yes,
is
sir.
there. They
Sure,
can
sir.
definitely.
Sure, sir. And if not now, you can contact sir later also
Yeah.
with any queries, any questions. So I
Okay, ma'am.
think,
Then
sir,
no questions. Then yeah.
there is no question. I think Ashok Bera, sir, has something to ask.
हेलो सर
Yes,
सर आपने
yes,
वो
sir.
वाला नहीं दिखाया सर
मैं सर टाइम पे
वीडियो
कमी
का
थी।
कैसे दिखा
मैं आपको वो पेपर दे दूंगा। मैं सर वो ओपन एक्सेस में
ठीक है
है
सर मैं
पेपर।
आपको मेल से कांटेक्ट कर लूंगा सर
हाँ,
नो
मैं वो
प्रॉब्लम
पेपर
सर
आपको
Yes,
शेयर
sir.
कर
फाइन
Yes,
दूंगा।
sir.
इट हैव ऑल द
ओके ओके
स्टेप्स
सर
एंड
ओके
मेथडोलॉजी।
ओके सर थैंक यू
Thank you. Yeah. Thank you, ma'am. Yeah.
Thank you, sir. Thank you so much for this very enlightening session. And sir, I thank you again. And please accept digital memento on behalf of our organizing team. Vikas, sir,
Yes. Yes. Ma'am. Thank you.
kindly share the digital memento. Vikas, sir. Vikas, sir,
No
are
issues,
you
ma'am.
there?
Later they
नहीं
can
नहीं
see.
जी
Yes,
मैम
sir.
स्टार्ट
Yes,
हो
sir.
रहा है स्टार्ट हो रहा है
They're sharing, sir. Just
जी
a minute. Yes. So kindly accept this memento
Thanks,
on
ma'am.
behalf of all of us, Gaurav sir,
Thanks, Gaurav
and all
sir.
the
Yeah.
organizing committee.
थैंक यू योगेंद्र सर आपने एक्सेप्ट किया हमारा निमंत्रण सर एंड प्लीज एक्सेप्ट दिस ये मोमेंटो
Thanks,
on
sir. Thanks
behalf
a
of
lot.
organizing committee and MNIT Allahabad and Galgote University are proudly hosted you, sir, and we are very fortunate that you have accepted our invitation, sir. Thank you, sir.
Thank you, sir.
Thank you,
Thanks
sir.
a lot.
Thank you, sir.
Thank you, sir. एक सेकंड
Sir, next speaker join him, Abhishek Kumar Tiwari. Gaurav sir,
Yunesh,
Yognesh sir.
okay. Please wait 1 minute, ma'am. I will
Okay.
talk to you.
Okay.
Yes, Anjali ma'am, Abhishek sir has joined.
Yes, sir.
जी.
Abhishek Tiwari, sir. Yes.
Am I audible?
Yes,
Yes,
sir,
sir.
you are
Yes, sir.
audible.
You're audible, sir.
Thank you, thank you.
Yes, sir.
So,
So for our concluding session today, this is our last session. We welcome Dr. Abhishek Kumar Tiwari from MNNIT Allahabad. Dr. Tiwari is an assistant professor in Department of Applied Mechanics at MNNIT Allahabad. He has earned his PhD in mechanical engineering from IIT Ropar, where his research focused on computational modeling of bone adaptation. Dr. Tiwari's research interests span computational biomechanics, oromechanics, mechanobiology, biofluid dynamics, and blast soft tissue interaction. He has authored over 30 peer-reviewed publications and holds patents for biomedical innovations. He has supervised multiple MTech theses and guides PhD students in skeletal mechanobiology, gait analysis, and AI-based clinical prediction. Sir has several projects funded by ANRF, DRDO, ISRO, MSL Limited, MOE, and University of Maryland, USA. He has been recognized with Best Paper Awards at several national and international forums. Uh, the title of Dr. Tiwari's talk today is In Silico Medicine for Postmenopausal and Aging Osteoporosis from Bed to Bench. This session delves into computational approaches in personalized medicine, an emerging frontier in geriatric healthcare and pharmacology. Welcome, Dr. Tiwari. We are very eager to hear from you, and the virtual stage is all yours. Welcome, sir.
thank you. Am I audible now?
Yes, sir. You are audible.
Yeah. So can I share my screen?
Yes, sir. Go ahead.
Yeah, please. So my slides are visible.
Yes, sir. Slides are visible. Please make it in full. Yes.
Yeah. Okay. Thank you so much. Thank you for giving me the opportunity to actually present few of my work, which I have done in past few years. So here I would be my title of the talk. This particular talk is In Silico Medicine for Postmenopausal Osteoporosis and Aging Osteoporosis, and how we can translate this in silico medicine to cater the needs of the patients which are having a particular type of disease like osteoporosis. So we are located here at in MNNIT in Applied Mechanics Department, and my research work basically lies in the area of computational biomechanics, mechanobiology, and experimental mechanobiology. So before going into this, I would also like to thank the organizers for giving me the opportunity to present here at this particular forum. So before going into that, we have to see some basics to understand like what kind of thing we are going to understand, and then what kind of investigations have been done in that area, so that you can have some insights to follow that and initiate some research work in that particular area. So as you know that in daily activity, you generally do walking, maybe sometimes some physical activities and all those things. In that particular case, the bone generally experiences bone, which is a skeletal tissue, you can say, and it is a basic structure of our human body. Generally sense those activity, and accordingly they respond and they maintain their mass in that particular scenario. Whereas if that particular scenario is not available, like we are not doing any physical exercise, or we are having certain disease conditions so that we are just lying on bed, or because of certain conditions we are not using our bones and muscles, then there is certainly a loss of the bone mass that our body generally experiences. So one of the very basic example, you might have heard about the Sunita Williams, where she stuck in the space station, and she has been compelled to be there for a longer period of time. So as you know that the space doesn't have the gravitational environment, or you can say under the microgravity conditions. So bones does not experience that particular stimulus, and that is why there is a decrease in the bone mass and the muscle mass. So that can be also observed in the basically one of the greatest example is the astronauts, where they experience this kind of challenge of decay in the bone loss. And once they return on the earth, they have to undergo certain rehabilitation because of this particular scenario. Whereas if you are doing certain physical exercises, like you are doing gymming, or you are doing the walking, running, or jumping exercises, then generally bone experiences the greater amount of the physical stimulus or the load, and in that case it wants to adapt itself so that it can sustain those particular loads. So you can say that the bone is a very live tissue which actually improves itself based on the demand, and it optimizes itself based on the when this demand is lesser. So I have just highlighted some of the examples over here, where you can see one of the example is like if you are having some physically challenged individuals, they can undergo the bone loss condition because they will not be using the exercises very much heavily, and that is why they can experience certain kind of porosity development in the bones. Then you can say about the astronauts, where they experience the microgravity condition, they can experience 25 to 30% loss of the bone due to exposure of 6 months. So if there is prolonged exposure to the microgravity environment, then the bone loss can also happen. Then spinal cord injured patients, which are basically lying on the bed for a longer period of time, going under the prolonged bed rest, they can also have this kind of bone loss. Or the bedridden patient because of certain kind of injury or maybe certain kind of diseases. Then if at the other side, if someone is using they are doing physical exercise or doing certain sports activity, then they can certainly gain the bone mass, which we can see from one of the example where the dominant forearm of a tennis player is having greater cross-sectional area of the humerus, whereas the non-dominant forearm, which she's not using much, that cross-sectional area is slightly lesser, and that is why the bone adapts itself based on the loading condition on the given particular bone. So that is the basics of the bone adaptation, or we can, in other terms, we generally call it remodeling. The cells generally sense this particular type of loading or this stimulus, and accordingly they respond for the bone formation or the resorption process or the removal of it. So if we go for the structure of the cortical bone or the any kind of a particular bone that we have inside our body, they generally have three types of cells. Like one is osteoblast, osteocytes, and osteoclast. So these are, if we go for the Hindu mythology, it is something like Brahma, Vishnu, and Mahesh. So one is the creator, where we have the osteoblast who creates the bone inside our body. Then we have the osteocytes. We generally sense the environment and coordinate between the formation and the destruction process. And the other one is the Mahesh, we can call it like osteoclast, which generally destroys the bone based on the requirement. So whenever there is a fracture, then these osteoclasts get activated, and then they remove the older bone, and then the osteocytes ask the osteoblast to come over there, and then they have to deposit the bone at that particular place. So this is basically a very well coordinated activity, so that the bone health is maintained within our body. So you can see some of the cells that I have just located them where you can find them. So if you cut the bone laterally, then you can find the osteocytes that will be embedded inside the bone. Then the section or the outer surface of the bone will be having the lining cells. Then at the inner surface, you'll find out the osteoclast. So whenever there is a stimulus, the absence of the stimulus, these osteoclasts will try to resorb the bone. They will reduce the cross sectional area of the bone, and then the bone can fracture, or they will increase the porosity. They will be removing the bone from a particular place where the stimulus is very, very low, or it is not favorable as per the requirement. Then if the stimulus or the loading conditions are basically well managed within the particular requirement, then the bone health is maintained, and both osteoblast and osteoclast, they make a balance between them. The resorption is nearly equal to the formation during the daily activity. Whereas if certain exercises or some particular type of activities are going on, then this particular bone formation is happening through the osteoblast.
Sir, your voice is not audible.
Increase the porosity in the bone. So here you can see some healthy bone which is having some porosity in the trabecular bone. You can see some porosity.
Abhishek, sir?
In the cortical bone, in the trabecular bone, as well as in the cortical bone.
Abhishek, sir?
Yes, yes.
Your PPT is not visible.
Okay, okay, 1 minute. Let me check
I
once
think
again.
the sharing has stopped.
Now is it visible?
Yes, sir. Yes, sir. It's visible.
Okay, so I was talking about, so have you seen, it was visible till here?
Yes, sir. It was visible. Yeah.
Yeah. So here the porosity is actually increased because of the more activity of the osteoclast cells, and then there is a reduction in the cortical thickness of the particular the you can say the cortical bone or the mid shaft part of the particular type of bone, like it can be femur or tibia or any kind of ulna or radius. So what is the solution? Solution is either you can go for the pharmaceutical drug, which can inhibit the activity of the osteoclast, but at the same time you will compromise the self renewal capacity of the bone, because once you stop the activity or inhibit the activity of the osteoclast cells, then it will not be allowing the resorption of the older bones. So the renewal activity will be stopped throughout your whole body rather than targeting at a particular place. So the another solution is a natural solution. You can design certain exercises which can stimulate the bone at a particular point, and it can enhance the activity of the osteoblast and the osteocytes, so that it can sense the external stimulus, like mechanical loading or physical exercise, and then they can respond to them, and then accordingly the bone formation can be increased at a particular place where it is required. So doctor generally prescribes the pharmaceutical drugs along with the physical exercises, both of them in combination, so that the things are getting improved at a particular pace, or it can be increased also. But however, the pharmaceutical drugs has certain disadvantage which I have highlighted. So for making any kind of loading regime, a certain type of research has to be done, so that we can understand if you are applying certain loads, then how the bone is going to respond to that particular load. So people have done certain animal experiments where they have applied loading on the bone in case of the in basically in mice. They have done the axial loading, then the ulnar axial loading, then 4-point bending, or different kind of loading regimes they have exploded, and then they have come to the conclusion that if you are loading the bone will try to deposit itself at a particular point where the strains are very very high. That you can see here, we have characterized the strain in a cross section of the bone, and we have seen that the strain was very very high at a particular place, and at the same point the animal experiment has also shown that the bone formation or the deposition was high at that particular place. But at the same time, we have also observed that where there is no stimulus, the bone was also happening. So what kind of the reason that could be causing this particular type of bone formation? So that was our idea to investigate why the bone is also formation is also happening at those places where the stimulus is low, or is there any kind of other type of mechanical stimulus that is actually provoking this particular bone formation where the strains are very very low, or you can see the stimulus are very very low. So what we have done, we have established a finite element model. We have scanned the tibia of the mouse. and then we have developed the 3D model. Then the scanning was also done to understand that where the bone formation has happened because of the loading condition experimentally. And then we have seen that the normal strain distribution has shown that the bone formation, the maximum bone formation was happening at the point where the stresses are very, very high or strains are very, very high. So what we have seen that if we have two different types of loads, for example, if we do the cyclic loading and where we do the rest inserted loading, the bone formation generally increases in case of the rest inserted loading. So that was the another type of inspection or investigation that we wanted to understand, that why this particular type of loading or the rest inserted loading is increasing the amount of the bone formation rather than the cyclic loading when they are exposed to the same loading condition or same amount of the maximum load. So what we have done, we have also tried to understood that this could be because of the fluid flow that generally happens inside the pores of the bone. So because these osteocytes are embedded inside the bone and they are connected through the pore space, and once we load the bone, the fluid tried to flow from the higher pressure zone to the lower pressure zone, and because of that flow, these osteocytes generally experience certain kind of shear stresses or the fluid shear, and that basically trigger the bone formation. So what kind of environment is generally or the particular type of stimulus which is actually increasing the bone formation, that we would like to understand. And at the same time, because of certain piezoelectric characteristics, the bone also initiates some electrical charges which generally flow through this fluid, and that also takes care of this particular type of mechanobiology. So we have developed certain model to compute the piezoelectricity, wet bone piezoelectricity. We have developed some poroelastic models, and then we have tried to understand that like what kind of things are except the strain, what other parameters that generally get developed within the bone which can regulate this particular bone formation. So what we have observed that if we load the bone, we can find out a nice distribution of the pore pressure within the bone. So here you can see where the bone formation was happening, the pore pressure is also high. Similarly, we have also found that the interstitial fluid flow is also very, very high in those regions where the bone formation was actually initiated because of the increased strain. So we can say that the interstitial fluid flow could be one of the governing stimulus which is actually regulating the bone formation. So here you can see the bone formation that is happening at the outer surface of the bone, and at the same place the interstitial fluid flow is also very, very high. That is from the you can say these are the two surfaces, that is the, we call it periosteal surface and the endosteal surface of the bone. So on the periosteum side you can see the more bone formation, and similarly the electric field that has been generated because of the piezoelectric effect of the bone, that is very, very high in this particular region. So based on that, we have developed certain model, and we have also tried to see that if we develop certain modeling techniques or we do certain in silico modeling techniques, then whether can we get the similar response that we are getting in the experiments or not. So we have, what we have done, we have updated the geometry based on where these stimuluses are very, very high, or the stimuli is very, very high. So we have obtained that if we take the normal strain, it actually matches the new bone formation at the periosteal surface. Then we have also seen that if we use the fluid motion, the advantage of the fluid motion is that or the interstitial fluid motion is that it actually captures the bone formation near those particular sites where the strain was minimal, but still we were getting the bone formation. So here, based on that, we have observed that if we do the high magnitude loading with rest insertion, the bone formation could be because of the interstitial fluid environment. Then further, we have one of the major challenge we have obtained in during the modeling, that like if we go for the two different surfaces, because their porosities are different, like the outer surface of the bone and the inner surface of the bone, then the permeabilities of these particular surfaces are also different. So we have first time introduced a a technique which is called nano indentation to obtain the to measure the permeability of a porous media such as bone over here. So we have engaged visitor rats groups which were having the age of 7 months, and then we have took certain cross sections of the tibia and we have embedded in the epoxy. Then we have done the nano indentation in presence of water along with using the spherical indentate. Then we have developed certain permeability estimation algorithm which generally work on the based on the least square method, and based on that we have tried to see that if we have a master curve that we have developed through the through different FEA solutions, that then what could be the permeability or the same response that we can get from the nano indentation data. So one side we have developed a model, finite element model, and other side we have developed the experimentation we have done, and so both curves were matched for that particular point where the given properties in the model gets matched with the experimental curve, that behavior we are getting from the numerical solution. So based on that we have predicted the permeability, and what we have observed, which is very interesting, that the endocortical surface of the bone is more permeable than the periosteal surface. So it means that if we are loading the bone, the fluid flow will try to be more on the endocortical side rather than the periosteal side. So the periosteal side will try to restrict the fluid flow, whereas the endocortical side will try to allow the fluid flow. So that was the major you can say the observations that we have found, and we have also published it in the Journal of Biomedical Behavior of the Materials, biomedical materials basically. So anatomical permeability was basically changing from the anterior to posterior and the lateral to medial side that we have observed. So it is actually the permeability is not only changing between the outer and the inner surface, but it is also changing the across the whole bone from the anatomical regions through anterior, posterior, and the lateral and medial side. So this also gave us an insight that if the permeability is also changing across the anatomical region, that has to be incorporated into the in silico model, and then we can predict the certain loading regime that could be beneficial for initiating the bone formation, because based on that we can control that what kind of loading has to be planned so that a particular level of the interstitial fluid motion can be achieved based on the permeability condition. Further, based on, as I have said, that this work is also related to the aging osteoporosis. So you know that in the elderly people, the osteoporosis is a more common problem. So what hypothesis we have drawn? So in case of the post-menopause condition also, because of the decreased level of estrogens, the osteoporosis generally happens. So we have also tried to understand that whether if the architectural changes are happening, then what will be the overall changes in the interstitial fluid environment, because interstitial fluid environment is regulating the bone fluid dynamics. And if we want to control that, we need to understand that if the architectural changes are happening, how this whole dynamics of the fluid is actually changing inside the bone. So we have again we have done certain animal experiment where we have certain osteoporotic visitor rats, then we have some skeletally mature rats, and then some elderly rats we are also engaged. Okay, then based on some micro CT scanning and synchrotron microscopy, microcomputer tomography, we have observed certain results where we can see some differences, and based on that we are working on the development of the models which can actually predict the interstitial fluid dynamics in the diseased condition. So here in the next slide we have done it on one of the facilities which is available in India in RR Cat Indore, where we have done the computed tomography for the control and the osteoporotic bones. So here you can see all the blood vessel porosity here in the red, whereas the green one is actually representing the porosity, which is because of the cells or osteocyte cells, where these osteocyte cells are generally housed or embedded within the bone. So here you can see in the osteoporotic bone, the vascular porosity was increasing, whereas the lacunar porosity was decreasing. And the similar thing we have observed in case of the other sample also, where the osteoporotic bone was having more cortical porosity rather than the cortical vascular porosity rather than the lacunar porosity. So it means that in case of the osteoporosis, the density of the osteocytes are also decreased because the porosity of the lacunar porosity where these cells are housed are also decreasing. So it means that because of the deterioration of this network of the osteocytes and the reduction of the osteocyte number, the capability of the osteoporotic bone is also decreasing, and that could be a challenge for developing certain type of loading regime. So we have to think in some other way also to understand the phenomena of this decrease in the lacunar porosity, why it is happening and why this vascular porosity is increasing. So we are working on that. So next thing what we have seen that as I have said, that if we are using different type of loading regime, like we are using rest inserted loading and at the same time we are using cyclic loading, then what could be the differences in the fluid flow? So what we have observed that, so once we have exposed the tissue to certain loading, then what we have observed that the cyclic loading is completing their cycle continuously, and because of there is no rest, they are not, the fluid flow is not present, or you can say the fluid flow get reversed within the bone within a shorter period of time. Whereas once we get the rest, the fluid flow is actually present for a longer duration within the bone. So once we are giving the, for example, we are giving the loading for 1 second and then giving the rest for the 5 second, then again loading it, so the fluid flow will be present for a longer duration of time rather than reversing their the fluid flow direction. So based on that insights, we have also seen that if we take the area under curve of this particular fluid motion, we have observed that the area under curve of these particular curves of the fluid velocity within these tissues, what we have observed that the fluid flow is present for a longer period of time, and the amount of fluid motion also increased for those cases where we have inserted in the rest. Whereas in case of the cyclic loading, the reversal of the fluid flow was happening. So that was the criteria, that if the fluid flow is present for a longer period of duration, that could be the cause of triggering of the osteocytes, which is actually coordinating the activity between these two cells, osteoblast and osteocytes. And further, we have also observed that if we increase the porosity also within the bone, then the fluid flow is decreasing. So that is what I was talking about. If we are increasing the cortical porosity in the osteoporotic bone, then the fluid velocity is actually decreasing. And similarly, either it could be aging osteoporosis or it can be postmenopausal osteoporosis. Wherever there is an increase in the porosity, we have observed that the fluid flow was decreasing. However, if we increase the frequency, the fluid flow was increasing. So it means that if you want to match up the fluid flow in the healthy bone to the level of healthy bone, you need to expose the bone to a higher level of frequency, and you can give certain rest intervals, and to achieve that particular fluid motion which is actually available in the healthier bone for the management of the bone resorption. So here you can see that with the increase in the frequency, the normalized fluid motion within the bone is increasing, whereas with the decrease in the porosity, increase in the porosity levels, the fluid motion is actually decreasing. And at the same time, if we talk about the time averaged pore pressure, then also if we increase the porosity, then the pore pressure is also decreasing, and similarly the fluid velocity is also decreasing with increase in the porosity. So at the lower porosity in healthier bone, higher fluid motion will present, triggering the more osteocytes, and the bone health will be maintained. Whereas in case of the osteoporotic condition, this will be causing the decrease in the fluid velocity, and it will diminish the response of the cells within the bone. So based on that, we have also compared for here you can see I have summarized for the different types of diseases. Like if we have a healthy bone, Then if we have a diabetes mellitus in the bone, the cortical tissues are having diabetes mellitus, then what could be the porosity levels? Then if certain type of osteoporosis, basically the postmenopausal osteoporosis is combined with the diabetes mellitus, then what could be the effect on the fluid motion within the bone, which could be responsible for maintaining the bone health. So here you can see that once we are going from the healthy to the diabetes mellitus and then the postmenopausal osteoporosis side, the porosities are increasing, and because of that the fluid flow is actually decreasing for all the frequency levels if we are exposing the bone at different frequency. Then if we talk about the rest inserted loading, whereas you can see the rest inserted loading, the amount of fluid motion is higher for a rest insertion of 10 seconds. So if we do the rest insertion for the 10 seconds, the fluid velocity or the fluid motion also increases with respect to comparatively to the cyclic loading. So what were the conclusion? That conclusion is that rest insertion in cyclic loading gives more time for the fluid to come to the rest, and that is why the triggering is more of the cells, and that could be best physiotherapy or physical exercise, which can actually initiate the more or the good response of the bone to increase the remodeling and the adaptation. And with increase in the cyclic loading frequency, the fluid velocity increases, whereas the fluid velocity decreases with increase in the porosity levels. So that could be a case of the osteoporosis, where the fluid velocity generally decreases with increase in the porosity levels. So what is the final outcome we can take up from here? That the rest inserted cyclic loading can be present for a greater period and could be involved in developing certain loading regime or certain devices which are going to trigger the bone for the fruitful response that to get from the cells. So we have also utilized this in silico model to understand what could be the effect of different types of physical exercises. Like for example, you are doing jumping, running, or certain type of walking activity. Then what could be the best one which can be helpful in improving the bone health? So based on that, we have done the gait analysis, and we have found out that what could be the ground reaction force that is coming on our body once we are walking, doing jumping or running exercises. So we have got three different type of characteristics. So one is, you can see over here, this is a normal general gait cycle where you see the two peaks. Once you are going to heel strike your ankle on the ground, and then the toe off region, and then again the heel strike region. So here you can see the two peaks, and based on that we have observed that then we have based on this loading curve or the force versus time curve, we have calculated the fluid motion within the bone. And we have observed that once we go for the jumping, the fluid velocity along with the pore pressure within the bone is very high. It means that it will be triggering more response within the bone. But once we do the analysis on the area under curve of the fluid motion, like when we plotted the fluid motion versus time, then once we do the analysis of the amount of fluid motion, we have found that the more amount of fluid motion was present in case of uh, the the uh, the basically in the running condition rather than the jumping, because jumping was only the peak force was only available for a very shorter period of time. So that was provoking the fluid velocity and pressure within the fluid within the bone for a very short period of time rather than for a longer period of time. So in case of this particular investigation, we have obtained that the fluid velocity could be present for a longer period of time once you are doing certain running exercise. So this also we have published in biomechanics and modeling in mechanobiology. So here you can see that the fluid velocity is increasing, but once we have done the analysis of overall analysis of the area under curve, we have obtained that the running was having the more area under the curve and was showing a greater response for the bone formation. So, and the same thing we have obtained that once we are increasing the porosity, the fluid velocity was decreasing in all the four cases. So if you are, for example, someone is having osteoporosis, then the running could be helpful for increasing the fluid velocity within the bone and giving the fruitful result rather than going for the jumping, because jumping can have some adverse effect on the mechanical failure behavior of the bone. So because of that, avoid that, and we can opt for walking or the running exercises to improve the bone health. So on some other side, we were also investigating like how this particular type of external fixation in the orthopedics generally changes the mechanical environment, and it regulates the fracture healing. So fracture, you know that in day-to-day life, you might have heard someone got bone fracture and then they are stabilized or having certain trauma or got under through the accident, traumatic conditions. Then the doctor generally use certain type of external fixators where they generally stabilizes the bone, and then the bone automatically heals on their own. So that is what where we were understanding that because of the certain mechanical environment, the healing can change. So from here, generally healing go through certain phases, and the callus formation generally happens between the fracture gaps. So here you can see the fusion of the two segments of the bone here. There it could be different from, it can start from the fusiform to cylindrical and then the hourglass, or maybe these kind of shapes you can say. So in that particular scenario, if the fusiform or the cylindrical shapes are there, then there is a good chance of the union of the bone, rather than if you are having certain type of fusiform shapes or incomplete form of the bone, then there is a possibility that the bone will not be completely union. It will not undergo the union, and then there could be a possibility of wrong or the malunion that can generally happen in case of the orthopedics. So what we have seen, we were actually trying to characterize that based on the computational mechanics, what kind of insights we can get. So what we have done, we have done a certain external fixator. We have in the FEA, we have used to actually characterize that what kind of fluid motion and other things can generally be there. And then we would like to see that what kind of changes that is generally happening. So what we have done, we have applied certain physiological loads, assigned certain properties to the callus, and then we have computed the 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 two conditions. Like one is the fixator condition and one other is the non-fixator condition. So we'll see that what is the happening if we are using the fixator, and once we are not using the fixator, then what could be the challenge in the mechanical environment, which is actually regulating the bone fracture healing. So what we have observed that once we are using the fixator, then the mechanical environment around the fracture site generally decreases. Whereas if we increase the gap size between the two segment bone segment of the fracture, you can say the fracture gap is increased, or we are having big fractures. Then in that particular scenario, also the mechanical environment is decreasing. So here, once we are not using the non-fixator or in the non-fixator condition, with the increase in the gap size, the all the stimulus which is actually taking part in governing the bone fracture healing is actually decreasing. So for example, you have a principal strain, deviatoric strain, fluid flow, or this is a well-established means stimuli which generally takes care of the fracture healing. So principal strain, deviatoric strain, and the fluid velocity inside the near the callus environment, and you can say the pore pressure is also decreasing. So non-fixator environment to going to the fixator environment, the fluid velocity is actually you can say the principal strain and the fluid velocity is actually decreasing. So why we use the fixator? We generally want to keep it in a optimal mechanobiological window so that the fracture can actually undergo the union. So what generally, what is the criteria of using fixator? That we want to reduce the strain and other stimuli in a certain mechanobiological window that is well established, so that these strains are so that the stimuli are within the limit which can trigger the bone cells so that they can start the healing process. So the same thing generally doctors do by their experience, that that they have to use the fixator, stabilize it to a certain level, certain type of tension they have to create around the fracture site so that the healing can be proper. So that is based on the experience thing. But if we go through the some logical side, what we have observed that the fixator reduces the stimulus around the callus within a mechanobiological window, and the shape of the callus has certain roles. So here in the fusiform callus, the fixator condition was actually creating the environment within a mechanobiological window, which can be fruitful for the new bone formation, or you can say the joining of the two segment of the callus. But once we go for a fusiform shape, which is non-desirable shape of the callus by the orthopedicians also, they have observed that the stimulus is very, very high. So in that particular case, it will never come to the mechanobiological window even if we apply the fixator. So it means that if the fusiform type of callus or cylindrical callus is developed over there, and the stimulus is far beyond the mechanobiological window, then even the fixator application will not be able to manage that particular uh, scenario. So in that case, there could be a certain arrangement, different arrangement to fill it with certain biomaterials or something that can be done to get that particular shape of the callus, so that the reduction in the stimulus can be done within the mechanobiological window, so that the cell can sense it and then respond it for the healing of the callus. So what we have observed that with increase in the fracture gap size, the strains were decreasing, the same deviatoric or the pore pressure, everything was decreasing. But if you talk about the comparison, then if you see here, this is the fusiform callus, this is the cylindrical, and this is the concave callus, where with the change in the shape also, you can see there is a huge increase in the stimulus. So if you talk about the fusiform, it is very well within the 10% of the compressive strain, which is actually required for the new bone formation or the good fracture to be good fracture healing, or the for the union to be done. Then whereas in the compressive principal strain, in case of in the cylindrical callus, or in the concave hourglass callus, which is incomplete kind of callus, in that particular case, these strains are very, very high and will not come in within the mechanobiological window of 10% or 5% deviatoric strain per mechanobiological window, so that it will not be healing properly. So that is why the fusiform callus is one of the, we can say, the gold standard callus, which the orthopedician generally want to see, and based on that they can say that yes, this will go under the union condition. And there can be certain cases where they will do certain pharmaceutical drugs or some management they will do, so that it can undergo the other type of callus can undergo the union itself. So here we can also see the same thing was happening in the pore pressure and the interstitial fluid distribution, where the pore pressure was also decreasing, and similarly the fluid velocity was also decreasing. But here you can see the direct comparison between the fusiform, cylindrical, and the concave hourglass callus, where the fusiform callus was having the fluid velocity well within the 5 micrometer per second, which is the desired fluid velocity for any callus to be healed. Then cylindrical callus was having slightly more, and the very large fluid velocity was observed in case of the concave hourglass callus. And similarly, you can see for the pore pressure, the concave hourglass callus was having more pore pressure, and it is also having non-uniform distribution of the pore pressure and the fluid velocity that we observed to the finite element analysis. So once we have what we have observed, that the fixator generally helps in the reduction of all the stimulus, either it is pore pressure, principal strain, deviatoric pressure, or fluid velocity, which is actually regulating the fracture healing. But at the same time, what we have observed that the fusiform callus is actually experiencing larger changes in the pore pressure and the fluid, basically the deviatoric strain and the fluid velocity, which is two of the major you can say the stimuli, which is actually regulating the healing callus. So what we have observed here, based on that, we have also developed a model which can predict the changes in the fracture healing based on days. So here we can see from day 1 to day 13. So this gray area is actually representing the higher stiffness of the bone, and this blue one is representing the lower stiffness of the bone, and this red one is somewhere in between. So from the starting from day 1, day 2, and day 3, we have actually simulated that how the fracture is going to heal over a period of time. So here you can see from day 1 to day 13, the callus has been particularly healed. So 15 to 30 days time is the time in which the smaller fracture gaps generally get healed. So here you can see the basically the healing process we have also simulated. So this could be one of the interesting area to understand the to assist the clinicians based on certain model which can predict the course of healing over a period of time. That would be very much beneficial based on seeing the callus geometry, callus shape, and the fixator condition. That would be helpful for the clinician to actually navigate through their clinical management. So I'm not going into more details in the conclusions. I've already highlighted that what are the conclusions from this particular study. So I would like to thank all the doctoral students and the master students and my collaborators, which have helped me in this particular study. One of my students is actually now doctoral student at McGill University, Canada. Another Pratik is also looking for he's also master students. This particular previous work is done by my master students, and we have certain collaborators which actually help us in doing these particular things. And so the acknowledgement will be going for the two projects which have been sanctioned, under which we have done this particular study. So acknowledgement to those two projects, from one from ANRF and another one is from the STARS. And these are the references that we have used for the development of this particular talk. Thank you. I would like to take queries from all of you. Thank you. Can you hear me?
Yes, sir. Yes, sir. Thank you, sir, for a very enlightening session.
Yeah.
And I open the stage now for questions. If any of the participants has any question for Dr. Tiwari, can ask now.
Yes, participant can unmute themselves.
Yes, and they can ask. In case you don't have any questions, I would like to ask myself one question. These in silico medicine that you talked about, can they be an alternative to the traditional drugs that we are using, or we can use them in combination? Will that be more effective?
Yes. Some herbal plants we have utilized from Pantnagar University. They have utilized certain herbal drugs which can be useful, but that is more at the pharmaceutical side. So that I have not explored. But yes, we have a collaborator which is actually using it in Pantnagar University to actually improve the bone health using some herbal drugs. So some natural drugs can also be utilized for the same things. Yeah.
That's great, sir. That's great. So I think we do not have any questions from the participants. In any case, they can contact you further also
Yeah,
for
sure.
any queries.
Sure.
So I would now formally like to thank you, Dr. Tripathi, for
Yeah,
that
thank
very
you.
thought-provoking talk. And please accept the virtual memento as a token of our gratitude from the organizing committee, from Dr. Gaurav, Dr. Yuvanesh.
Thank you. Thank you.
Thank you, Abhishek,
Abhishek,
sir.
sir.
Thank you.
Thanks
Thank
a
you.
lot.
Thank you.
Thanks
Thank
for
you.
sparing some time.
Yeah, sure. Thank you. Thank you.
Okay.
We will have a cup of tea in physical mode, right?
Sure, sir. I'm
Sure.
waiting for you.
Thank you. Thank you.
Thank you, sir. Thank you for your time.
Thank you. Thank you.
So this brings us to the end of today's session. And feedback form has been shared in the chat box for all the participants. You can fill it now. Finally, a very heartfelt thank you to all our distinguished speakers for today for sharing their deep knowledge, and to all the participants for your enthusiasm, for their engagement throughout the day and interaction with the esteemed speakers. On behalf of the organizing team, I thank you all once again, and I look forward to your continued participation in the upcoming sessions, days of the Faculty Development Program. So have a pleasant evening. Thank you, all of you. Thanks again. Gaurav sir, or कोई information here? Continue.
No, ma'am. No, ma'am. You can conclude.
Okay. So we conclude the session here. Hopefully it was very enlightening for everyone, all the participants. And if you have any queries, you can contact the speakers personally also. And kindly fill the feedback form, everyone. The link has been shared in the chat box.